Gaming, Shweta, hello Gopika, hello Madhav, hi Manath. Welcome aboard. This is Shreyas here, your physics master teacher at Vedantu, and I'm going live. And today is a very important one-shot marathon. Marathon means it's going to be a big session, and one shot means we are going to cover all the topics, all the important topics which are important from CBSE point of view for your upcoming term 1 board examination. And in today's class, what are we going to do? Let me just show that to you. We are going to cover charges, fields, forces, then we are going to move towards potential energy, potentials, and then we'll also move towards dipoles and dielectrics, and then flux, Gauss Law and its applications, and then we'll also move towards capacitors and finding equivalent capacitors, and also the different types of capacitors and their formulas. All of that we will then go to current electricity and solving circuit problems along with some questions on instruments. And when we revise through these topics, we are going to do lots and lots of practice. That means we are going to do questions. So these questions are exactly of the level of CBSE Term 1 board examination. Some questions can be slightly tougher, but most of the questions are meant for CBSE board examination. So all of this with me, Shreyas, your physics master teacher, leading the physics department at Vedantu, having training kids for almost like a decade. Welcome Manath, hi Gauri Shankar, hello Dikshika, hi Neveli, hello Manikandan, welcome Surya, nice to see you. Exactly, this is for board examinations, and some of you are coming here after quite some time, I can see that. And nice to see that some of you also changed your display picture to the Warriors logo picture. Yep. Will the CBSE give the question paper? Yes, the CBSE will give the question paper, Sankar, definitely. And like I promised to you in my lecture last time that I'm going to do revision of all the chapters for term 1. So today it's more of electro. Tomorrow it's going to be magnetism. And I'll try to come live at 6:30. But yes, make sure that you are subscribed and you have also hit the bell icon so that you do not miss our notifications and any updates that come through. So just like that the KVPY examination dates are also out, and that's on 9th of January. Same way, many updates, our lectures, and let me tell you, there is a special plan just before your physics board exam, before your maths exam, and so on and so forth. I'm pretty sure you want something to be done after each and every exam till the next exam. In that gap, you want preparation to be done. Do you want us to do something? Then yes, please go ahead and smash the like button and also hit the subscribe button so that you do not miss all those things that I have planned for all of you. Okay, so let's get going. Oh my god, PRC, you are from my Drishti batch of 11. Nice to see that you have now come to the 12th standard and all excited. Good to see all of you. Good to see all of you. So this will be for at least 2 to 3 hours. Okay, 2 to 3 hours. That's what I have planned it for. All right. Okay. And oops, Darpan, I think I now remember. Yes, I remember that funny incident. I remember one kid asking that doubt. All right. So yes, Venkatesh, this will help you in NCERT. So we are going to touch upon all the topics in one shot. It's more like a revision plus problem solving. It will give you that confidence in problem solving, because remember, this time term 1 examination is MCQ based. It's objective based. They are not going to ask you derivations. They are not going to ask you give reasons. But yes, there will be reasoning questions in the form of MCQs. So quickly, let's go through the properties of charge. Yep. So Karuna, definitely, I will put up all the formulas in the Telegram channel link as well. Okay. So one thing is that charge is conserved. It cannot be created nor destroyed. The total amount of charge, all right, in this universe remains constant. So you cannot create new net charge. Okay. So if you basically take a neutron and split it, you will get one positive, one negative, but the total charge still remains the same. All right, that's very important. Second thing is the charges are always quantized. That means they are always in multiples. They are always in multiples of the most fundamental charge, which is E, which is 1.6 into 10 to the power minus 19. Be it positive, be it negative. Okay, next thing, charges are scalars. That means you can just add and subtract them. And remember, whenever you charge a body, it's the electrons which go from one body to the other. Alright, cool. So Ganesh, don't worry, if you have not practiced many chapters, this session will help you, plus tomorrow's session will help you, plus the sessions that I have planned before the physics board examination will also help you. I have planned more than 2 sessions for you. Okay, so I do not know your name, so I cannot take your name. I can just see good and bold girl, that's all. Okay, so gaming, just refresh, probably that will help. And hello Kavi, welcome to the session. Now, the next important thing is the different types of charging. One type of charging is when you take a conductor and you bring some charged body close to it, then charges are induced. So induced is when you do not touch, but the charges get induced. That means some of the charges will start flowing. Like for example, you bring this rod close to this conducting sphere, the electrons on this conductor will go towards this positive charge, but they will not be able to jump. Because these electrons have ditched these charges over here, you will see a positive charge developed over here. These charges are called as induced charge because they have not conducted via some body. The next method is conduction, when you charge a body by touching or rubbing it. So you rub 2 bodies, or you take a charged body and touch some other body, charges actually end up flowing via conducting path, via a wire, via some material. That is called as charging via conduction. Okay, I hope you all remember that. And let me ask you a simple question. Till when do charges flow? What is the condition that should be met till which the charges will flow? Come on my warriors. So how positive charge will induce, Madan? Because the electrons have ditched the other atoms over there. So what has happened is, when you bring this positive charge, what will this positive charge do? It will attract the electrons, it will come here. If electrons leave, what does it create? It will create a vacancy. That vacancy is nothing but your positive charge. Yeah, till that comes into equilibrium. But no, a lot of you are saying both become same. No, charges flow not till the charges become equal. It flows till potentials become equal. Remember that. It need not be that the charges are equal. Charges can be more, less, etc. But the potentials have to be equal. That's the time till which the charges are going to flow. And here is your first question coming up on your screen. There is a polythene rubber piece which is rubbed with wool, and it is found to have negative charge of 3.2 into 10 to the power minus 7 Coulomb. And the question is, estimate how many electrons got transferred and from where to where, and whose mass increases and whose mass decreases. Come on, quickly. I will give you probably 30 to 50 seconds because these are the general time limits that you should set for yourself while solving the CBSE mock papers or while solving sample papers. Okay, let's see how many of you can do this. What do we have? We have a polythene piece. So this is polythene. Okay, and we have wool over here. Okay, so this is wool over here, and it is clearly mentioned that when you rub that polythene, it is found to have a negative charge. So when you rub it, polythene is found to have negative charge. That means positive charge will be developed on the wool. Now understand that if polythene got negative charge, it clearly means that the electrons have jumped from the wool. The electrons have jumped from the wool to the polythene. That means the mass of the wool has decreased and the mass of the polythene has definitely increased. So that's one thing I can for sure say. That means option B, or rather B part, is done. Okay, this can come in case study also, this can come in objective also, like whose mass will increase, whose mass will decrease, you don't know. And some of you also posted the answers, like Kanishma, very good, Sankar, and Manikandan too. Very good, very good. So the mass of the wool will decrease. Very good, many of you said that correctly. So the last thing is, how much is the number of electrons transferred? We know that the charge is this much. So Q is equal to number of electrons into charge of each electron. So the charge is 3.2 into 10 to the power minus 7. N I don't know. E is 1.6 into 10 to the power minus 19. So you can see 1.6 goes with 3.2 2 times, and 10 to the power minus 7, and this will become 10 to the power minus 12. So therefore n will become 10 to the power 12. So that's the answers. Okay, but it is, yeah, oh sorry, this is 2 into, because that 2 is also there, yeah, my bad. So 2 into 10 to the power 12. Yep, very good. So that's the answer. Understood? Clear? Okay, let's move on to the next question. Yep, so 2 into 10 to the power 12, and Wool's mass will, okay, I think, why is this mentioned as decrease? I think that's wrong thing. Wool becomes, yeah, wool was becoming positive, polythene will become negative. Yes, that's correct, fine. Okay, great. Let's move on to the next question. We have an uncharged conductor and it is brought near a positively charged conductor. Then what do you think will happen? Very interesting question on bringing a conductor near another uncharged conductor. Very interesting. Visualize it and think one of them is correct, MCQ based. Come on my warriors, figure this out. So we have an uncharged conductor. So this is uncharged conductor A, which is brought near a positively charged conductor. So maybe this is a positively charged conductor. Okay, so this is positively charged conductor B. So what do you think will happen because of this? Many of you are saying D, some of you are saying A, some of you also said, one of you said C as well. Well, most of you are inclined towards D. Well, see what will happen because of this positive charge. The electrons over here, they will start moving this side. They will start moving this side. And once the electrons start moving this side, there will be negative charge here. And that means there will be a positive charge induced. What are these? These are induced charges. Now, what will happen next? Negative charge will get pulled. They will get pulled by attractive force. Okay? Negative and positive will attract. Positive and positive will repel. Okay? They will repel. Now you will think, sir, attraction and repulsion both are opposite. So hence net force is 0. But that's wrong. Think again. The negative charges are closer. So the attraction is more. Repulsion is less. So hence the net force is basically going to be attraction. So the charge on, total charge on B will not change. Obviously the charges are not getting transferred. Charge on B will still remain as it is. The only difference is that they will now end up attracting each other. Okay, charge on B will decrease. That's wrong, Karuna, because B has not been touched. Remember, it has been brought near. It's not touched. If the question said they are touched, yes, then the charges will get exchanged, or basically charges will go from B to A and then it will reduce. But that's not the case. Hence the correct answer is option D. Understood? Clear? Yes, Priya, definitely. This will be also useful for JEE mains. Definitely, bacha. Okay, Ramya, no, it is not C for Capto, unfortunately. It will not decrease because it has just been brought close, not touched. Be careful. Don't make these kind of mistakes. That's what happens. Guys, that's the reason why you are attending this class. You are going to learn small things. You're going to see and find small mistakes in your thinking, and if you correct them, only then you can get very good marks in the upcoming term examination. Let's move on. Coulomb's force. Coulomb's force, what does it say? Inverse square law. Whenever you have two charges, the force of attraction or repulsion is proportional to the product of the charges. So you can see product of the charges and inversely proportional to the square of the distance between them. What is this K? K is the constant, Coulomb constant, 1 by 4 pi epsilon naught. What's the value of K? The value of K is 9 into 10 to the power 9. Okay, like you can see over here, 9 into 10 to the power 9. You should remember this value. The second value you should remember is epsilon naught, which is also called as permittivity of free space. And that is 8.85 into 10 to the power minus 12. Keep this in mind. Okay. Yes, Murdu, we are going to do assertion reason questions as well. It's a combination. You're going to see all kinds of things. Okay. Not everything will be of the same type. Alright. And when you change the medium, what changes is basically this epsilon naught. So if you change the medium, multiply it by the dielectric or relative permittivity of the medium. So this ER gets multiplied. What is this ER? Relative permittivity, or also called as the dielectric strength of the medium. So when you change that medium, just make sure that you no longer use epsilon naught. It's epsilon naught into that relative permittivity. Alright. Next, whenever you have multiple charges then remember each charge will apply its individual force. That principle is called as the principle of superposition. Meaning, if this one charge was there and if this second charge is here, the second charge might exert a force on it, let's say F2. Let's say there is a third charge over here. This third charge will exert a force on this guy, F3. So each charge exerts their force irrespective of whether other charges are there or not, and each charge ends up experiencing all the forces due to all the charges. So the total force will be the vector sum. So this force plus this force, you add it, you will get the net force. So the net force on any charge is just the vector addition, not the scalar addition of all the forces acting on it. That's one thing. And what is that called? It is also called as superpositioning principle. Superpositioning of the forces on electric charges. Keep this in mind. Yeah. Now, we are going to do a problem on that. Don't worry. We are going to do a question on that. Yep. Yes, you can take it as 8.8 also, depending on the problem. You see approximate values. Yeah. Need not. Yep. Now, field. What was field? Field is created around every charge. Field tells you that yes, there is a charge present, and the lines, if they are close, the field is strong, and if the lines are far, then the field is very weak. Field always starts from positive charge. It always terminates on the negative charge. More the charge, more the lines. Less the charge, less the number of lines. Keep this in mind. And you will never see two field lines cutting across each other. That is not allowed. Okay. Then the direction of the field always tells you the direction of the force. In fact, the field due to a point charge, field due to any point charge at any distance is given by K. You can see this 1 upon 4 pi epsilon naught. What is it? K into Q divided by R square. There is no Q1, Q2. It's KQ by R square, simple terms. And the force on any charge in somebody else's field. Let's say I place a charge here, Q, and this positive charge is creating an electric field E. Then the force on this charge Q, okay, the force on this charge will be given by charge into field. Keep this in mind. Rather, field is nothing but, force per unit charge, Newton per Coulomb. So that's why force will be charge into the external field. Keep this in mind. Alright, so that's what I have written down over here. Okay, same like forces, fields also can be added, but not scalar addition. They are vector quantities. So make sure you take into account the directions. So each point might create different fields, and when you find the net field, add them up vectorially. So for example, this positive charge and negative charge, I want to find the field at this point. Due to this positive charge, there is a field here. Okay, this is the field due to positive charge. Due to the negative charge, there is a field here. This is field due to negative. So the vector addition of both of them will be here. So this is basically the net field, vector addition. Very good. Let's start solving questions on this. Yep. Let's do this. Very good. Come on, my warriors. I can see all your chats. Perfecto. You are revising as you are typing, and I can see your confidence in your chats. Keep that spirit up. Keep that spirit up. So, Surya, the SI unit of charge is Coulomb, but it is not a fundamental unit. The fundamental unit is 1 ampere, and 1 ampere when passed for 1 second, the charge that flows is called as 1 Coulomb. So ampere is more fundamental than Coulomb. That's how it has been defined. So 1 ampere of current when flows for 1 second, then you get 1 Coulomb of charge. I hope that is clear. Okay. So if you have two spheres which have charge plus 10 and minus 90 microcoulombs, and they attract with a force of F, now if they are kept in contact for some time and then separated, what is the new force between them? Very interesting question. Let's see how many of you can do this, my warriors. Alrighty. So what do we have? We have plus 10 and minus 90 microcoulomb. So this is one charge, this is another charge, and they are attracting each other with a force of F. So what will that F be? Using Coulomb's law, it will be K into Q1 into, we are just interested in the magnitude, into Q2, which is 90 divided by R square. Now, when you touch them, the charges will get split, But because the spheres are identical, that's why the charge on them will be equal. So there will be equal distribution of charges, and remember, charge should be conserved, and charge is always conserved. Keep this in mind. So what's the total charge initially? You can add it. 10 and minus 90. How much is it? So the total charge is basically 10 minus 90, which is basically minus 80. So minus 80 will get divided here. So minus 80, if you divide it into 2, you will get minus 40 and minus 40. Correct, my warriors? Now, what will these two things do? They will obviously repel. Let's say this is the new force F1. Correct? They will all repel. So what is the new force F1? K into this charge into that other charge divided by R square. Now you just divide both of them, you will get the answer. So F1 by F will be K cancels, R square also cancels. So 40 into 40 divided by 10 into 90. So you can see 0, 0, 0, 0 cancels. 4 4s are 16 divided by 9. So 16F by 9 is the answer. You can see that F1 will be 4 4s are 16. This is 9. This F from below comes over here. Is that understood? Very good. I can see all of you have answered C. Perfecto. Looks like you are getting good marks in this kind of questions for sure. Perfecto. Moving on to the next question on electrostatics. Oh no, Srashti, you have not been blocked. You are still, your comments are visible, and no, I will never do that. Just because you're not commenting does not mean I'm going to block you. No, I'm not mean. Okay. So there are point charges, +2, -3, -3. And they are kept at vertices A, B, C respectively of an equilateral triangle. Okay, interesting. As shown in the figure. Now you might be wondering, sir, where are the options? See, this can come in a passage, this can come in a single choice. It doesn't matter. Okay. The question is, what should be the charge kept over here and the sign of it so that this charge A remains at equilibrium? That's what is given. So the charge at A remains at equilibrium means the field, okay, the field, or rather the net field at A is basically 0. Now how can the net field at A be 0? It's very easy. I'll tell you how. Imagine these are two negative charges. Forget this A's charge. These two, B and C, are negative charges. They will create two fields, one here and one here. These are the two fields created by it. I'll call it E1 and E1. Together the resultant, okay, the resultant will be like this. Together the resultant will be like this. So the resultant of E1, so it's the resultant of the ones out there is going to be, think like this. This is equilateral triangle, so this angle will be 30 degrees, correct? E1's cos component and this E1's cos component. Both these E1's cos components gives the resultant along the line AM. Everybody getting it? Everybody getting it, my warriors? Think about it. Yep. Think about it. So this field and this field together will create a resultant field here, and this is equilateral, so this is 30, this is also 30 degrees. So the cos 30 component will give the resultant field. So can I say it is E1 cos 30 plus E1 cos 30. Now what is cos 30? √3/2 and 2 times of it. So 2 times of E1 into cos 30, which is √3/2. 2 cancels. So I will get this as E1 √3. Fair enough. What did we conclude, or what did we start our discussion from? The net field at that point should be 0. So if these two charges are giving E1 √3 field, that means exactly opposite field must be there like this to cancel it out. From whom will this field come? Let's say I call this field as E2. This will come from obviously a positive charge placed over here. Understood, my warriors? This will come from a positive charge placed over here. That will create another field exactly opposite to it, and these two will cancel to give the net field as 0. That's it. So this should be equal to the field E2 in order to cancel. Fair enough. Now what is E2? E2 will be KQ by R square. K is K. Q I do not know. R is this distance. R is this distance AM. How much is AM? That is very easy. AM is AC. This is 60 degrees, right? So AC sine 60. What is AC? AC is 20. Sine 60 is root 3 by 2. So basically this is nothing but 20 into root 3 by 2, and this is whole square. Okay, so KQ by R square, that's the formula that I have used. And on this side, what is E1? Field at this point due to this charge over here. K into charge, which is 3 magnitude wise, divided by distance, which is nothing but 20, and square. I know it's in centimeters, but I don't bother because this side and this side both are centimeters, so they will get cancelled. So you don't have to really worry about it. So the best part is many things get cancelled, like over here, K will get cancelled. This 20 square and this 20 square will also get cancelled, and I think you will be just left with Q. 2 square is 4, root 3 square is 3. Okay, and here we have I think, oh, that was K1 root 3, right? Yes. So K1, oh, this root 3 was also there, so I just forgot to put that root 3 over there. Cool, now it's fine. So 3 and that root 3 over here. So therefore Q will be equal to 3 3s are 9, root 3 divided by 4. That should be the answer. But this is in microcoulombs, remember that. Yep, done. So it's a positive charge of 9 root 3 by 4 microcoulombs. Perfecto. Understood? Sir, will physics paper be fine? Definitely, Yogita, it will be very fine. If you attend these sessions and the sessions that I'm going to conduct in the next few days, plus watch my strategy session, trust me, it will be very fine. Yes, it is 9 root 3 by 4 microcoulomb. Perfecto, we got it. Yeah. So to sum it up again, what has happened? These two charges have created field here and here. I have found the net field down. Fair enough. This point charge which I am going to place will create a field this way. So this field should be equal to this field in order that this point will remain at equilibrium. That's all I have done. Okay. Why did we consider field and not force? Very interesting question, Rahulji. Even if we considered force, what will happen? So the net field due to both the E1s and the field due to this charge. So this was E2 and this was E1 net. Remember, charge into field, charge at A into field, will basically give me the force. So it doesn't matter. You will see that the charge will anyways get cancelled. So that's why I did not consider force. It's anyways going to, get cancelled in any one of the steps. So why bother about it? I hope that is clear, Rahulji. Alright, moving on to the next question. Okay, let's see what it is. Okay, but before that, formulas for potential and potential energy. So potential, how do you define it? First of all, if there is a point charge, if you have a point charge Q, then the potential at a distance R is given by KQ divided by R. So that's the formula for potential. And it is also, the work done per unit charge. How do you define it? Work done per unit charge to bring it from infinity to a distance R. That's also how you can define it. And if you don't remember these things, it's okay. I mean, even if you don't remember this, I'll tell you, it's very easy to remember in different way. Electric field is negative dV by dr. If you remember this is very easy, because if you take dr on that side, just take dr on that side, it will become E dr is equal to minus dV. Now you integrate, so it will become minus integral dV will be integral E dr. So if you know this, you will automatically get this expression. So don't have to worry about it, but I doubt there will be questions on it, such complicated integrations in board examinations, but you should know the formula at least. Last thing, energy, potential energy. What's the difference between potential and energy? See, simple thing. If you have one charge, let's say Q1, it at a distance, let's say R, what does it have? It has potential. There is no energy, but there is potential. Potential means ability to gain potential energy. At that point, there is no energy. It's just having that ability, that capability to get energy. When you actually put a charge, when you place a charge, when you place this Q2 charge, then you have energy of that system in joules, and that energy is K Q1 Q2 divided by R. Okay, so that's the difference between energy and potential. Potential is due to charges. Look at the words. But here potential is due to the charges, but potential energy is of the charges. It belongs to them. It's not of the charges at some point. I hope that is clear. Definitely. Okay. Now, yes, Neville, we are going to have physics paper discussion in the, not even in the evening, in the afternoon, immediately after the physics paper is over. And the time when your maths exam is over, after that, you're going to have physics preparation for the next few days. That's also going to happen. Here we have our next question on your screen. Let's see how many of you can do this. Yes, Mahi, we'll put the PDF in the Telegram group. Okay, Telegram group. Very, very important. Yes, Madan, yes, Q into V will also give you potential energy. That also works. Okay, because you can see U is K Q divided by R and V is K Q divided by R. So basically U is nothing but V into Q. So this is also a formula. Yep, you can remember it. Definitely. Okay, so let's see how many of you can do this. Many of you are saying -8 I cap. Yep, let's see, minus 8 I cap. All right. So V is given, E has to be found. So electric field is minus dV, but this is a function of x, so differentiated with respect to x only. So minus d by dx of 4x square. So derivative of 4x square will be nothing but 4 2s are 8 x. That's it. Now minus sign signifies it is negative x axis. Okay, and the question is at x is equal to 1. So at x is equal to 1, the magnitude of the field will be 8 into 1, which is basically 8. So hence it is 8 along the negative x axis, which is option A. Yeah. Surya, we are doing this for the board examinations only. This is for the term 1 board examinations. Yep, this is exactly for the term 1 board examinations. Let's move on to the next question. Which of the following is not correct? Which of the following is not correct? So Prabhas, I got almost full marks when I wrote my J back then. Okay, so which of the following is not correct? Electrical potential energy of a system can never be zero. Electric field travels from higher potential to lower potential. Electrons are pulled towards higher electrical potential. Electrical potential energy of two repelling charges increases when brought closer. Let's see how many of you can do this. Come on, my warriors. Madan says A. Interesting. Let's find this out. It is going to be a very interesting question. Let's see how many of you can do this very quickly. You should not take more than 1 minute, okay, to solve the question, because then you will lose out on time. Okay, so try to solve this as quickly as possible. Come on, my warriors. Many of you are saying A. Sure. Okay. Its magnitude. Why we are saying positive? Yes, magnitudes are always positive because it is the modulus. It's the absolute value. That's why. Okay, so the correct answer is actually A. Perfecto. Some of you said B. I was not sure why. Some of you also said C. That's not correct. Electric potential energy of the system can never be zero. It's possible that the system's energy can be zero, because you will have terms like K Q1 Q2 divided by R plus K Q2 Q3 divided by R plus, let's say, K Q1 Q3 divided by R. Maybe there are 3 charges. Okay, 1 2 3. Possible that this term is positive, this term is negative, this term is positive. The total sum can be 0. Yes, the total sum can be 0. Who says it can't be 0? It can definitely be 0. Electric field travels from higher potential to lower potential, that's a fact. So if this is a potential line, this is also potential line, and if this is high voltage and this is low voltage, electric field will always travel from high voltage to low voltage, and that too it is always perpendicular. That's a rule. Electrons are pulled towards higher electrical potential. See, if you place an electron over here, then electron is a negative charge. The force won't be in the direction of the field. The force on an electron will be opposite to that of the field. So electron gets pulled towards the higher potential. So that is also correct. Electrical potential energy of two repelling charges increases when brought together. Now imagine you have repelling charges, that means two charges like this. You bring them close to each other. What will happen? The formula for potential energy is K, Q1, Q2 divided by R square. When you bring them close, what happens? This R square decreases. So that means the denominator decreases, so the entire expression increases. It becomes more positive. So hence the energy of that system will increase when brought closer. So D option is also correct. But the question asks you which of the following is not correct. So only this is not correct. Understood? Yes, just like like poles of magnet won't like it close to each other. Thank you, Prabhas. Alright, moving on to the next question coming up on your screen. Here we have 3-point charges Q1, Q2, Q3. They are placed at these coordinates. Find the electrical potential at origin. Very interesting question. Let's see how many of you can solve this within a minute. Okay, because these are CBSE level questions, and if you are preparing for JEE, this is like easy cakewalk for you. But even if you are preparing for CBSE alone, still it's not that difficult. This is X, this is Y, this is Z. So you are placing Q1 charge, which is 1 microcoulomb at X axis at 1 meter. So this is where Q1 is. Then Q2, which is negative charge, you are placing it on the Y axis. So this is where Q2 is. And Q3, you are placing it somewhere on the Z axis. Now all of you might be thinking, sir, we have to do vector addition, I cap, J cap, K cap. No, potential is a scalar quantity. This is a scalar quantity. So you don't even have to worry about the directions. So the total potential at the origin will be potential due to 1 plus 2 plus 3. Simple addition. So potential due to the first charge will be K, okay, into Q1. What is Q1? 1 microcoulomb. That means 10 to the power minus 6. Okay, divided by the distance. What is the distance? 1 meter. So 1 meter plus K into what is the charge to? It is negative. So minus 2 into 10 to the power minus 6 at a distance of 2 meters. So this is 2 meters. Last is nothing but Q3, which is 3 microcoulomb. So 3 into 10 to the power minus 6 divided by distance, which is nothing but 3. Now you can clearly see what is happening. This 2 gets cancelled. This 3 also gets cancelled. So you can see that K value is common. 10 to the power minus 6 is common. From here you have 1 plus, minus 1 plus 1. So minus 1 plus 1 is 0. So you just have this number. K is nothing but 9 into 10 to the power 9 into 10 to the power minus 6 into basically 1. So this is going to be nothing but 9 into 10 to the power 3 volts. Let's see how many of you got this answer. Oops, many of you made a mistake. It's not 18 into 10 to the power 3. It's 9 into 10 to the power 3, 9,000 volts. 9,000 volts is the answer. Very good, Money. Very good. Some of you got it. Some of you got it. Perfecto. Perfecto. Is drop a year placement or resume anything else? I'm not sure what your question is, Prasad. K, can you be more specific? Can you be more clear about it? Okay, moving on to the next question. Okay. Okay, so Angna, I think both of the things are very important. You have to do objective questions plus HCV if you want to crack JEE mains. But for boards, NCERT, exemplar and your Tattva module, your assignments, sample papers, school papers, more than enough. Okay, so 2 points A and B are 2 centimeters apart, and you have a uniform electric field E which acts from A to B. The electric field is this much, the particle's charge is this much, which is taken from A to B along AB. Find the work done. Find the work done. Yes, for potential, simple addition is enough. Remember, we solved a question on field. That time we had to do vector addition. We took cos, sine components. But for potential, there is no need of cos or sine components. Okay. And thank you guys for liking the video. And in case you have not loved and subscribed, do not forget to hit the like as well as the subscribe button so that you do not miss my next classes. Now, in this situation, let's first start with the diagram. We have A and we have B, and we have gone from A to B, whose distance is how much? Okay, let's see how much is the distance. Is it given to 2 centimeters apart? So this is 2 into 10 to the power minus 2 meters, and there is electric field also. The electric field is given as 200 newtons per coulomb, and the charge is 10 to the power minus 6. Okay, 10 to the power minus 6 coulombs. That means the force on it, the force on the charge, which is field into the charge, okay, that will be the force on that charge. Now the question is, what is the work done by the field? Work is force into displacement into cos theta. What is the force? 200 into 10 to the power minus 6. What is the displacement? Displacement is 2 into 10 to the power minus 2. Cos, force and displacement are in the same direction, so angle is 0. Cos 0 is 1. Now 2 2s are 4. These two zeros and these two zeros go away. These two zeros and these two zeros go away. So I'm just left with 4 into 10 to the power minus 6. And remember, cos 0 is nothing but 1. So that's why I'll get these many joules. 4 microjoules. How many of you got it? Very good money, very good Cholan. Excellent. It looks like some of you are really quick, and looks like some of you are going to get 35 out of 35. How many of you are going to get 30 plus? 30 plus. How many of you are sure you're going to get 30 plus out of 35 in the upcoming board examinations? How many of you are confident? Let me know in the comment section right now. Perfecto. Moving on to the next concept. Very good PRC, very good Hungry 7. That's the Josh. Keep it up. Sanjay, why do you want to take a drop right now? I mean, if you have already, if you're in 12th, you still have a lot of time. You can prepare and might as well, you know, give in your best shot this year itself. And let me tell you, there is a crash course which is starting for all of you, especially the 12th standard students who want to, you know, revise the entire 11th and 12th standard syllabus. That's on 6th of December. So you can definitely enroll yourself in the crash course, which will cover the entire syllabus. All right. Now, let's do the next concept. I can see the confidence in all of you. Proud of you, bacha log. Very, very happy. Keep it up. Keep it up. Dipole. What's a dipole? Pole is charge. Di means two. Two equal charges but of opposite sign are called as dipoles. And there is a dipole moment which always goes from negative to positive. The dipole moment is charge into the distance. In your textbooks, I have seen this. There will be a positive charge, there will be negative charge, and this distance will be given as 2L, and then they write dipole moment is charge into 2L, and that creates a lot of confusion. Instead of that, I prefer remembering this charge into distance. D is the distance between them. Is it a vector quantity? Yes. What's the direction? Always from positive to negative or negative to positive? Positive to negative or negative to positive? Oh no, Pooja, I'm just wearing my jacket because it's very cold out here in Bangalore. Okay, that's all. But trust me, otherwise I'm not out of mood or anything. All right, so I'm all full of josh. Sometimes my body gives up, but it's fine. Thanks to all your love and all. Yes, always from negative to positive. Not from positive to negative. Negative. Field lines go from positive to negative. You see this? These black lines. What are these black lines? These are field lines. These are field lines. They go from positive to negative. But the dipole moment has been always taken from negative to positive. Keep this in mind. What are these blue lines and red lines? What are these blue lines and the red lines over here? These are equipotential lines. Equipotential lines. And like always, you will see field lines are always perpendicular to the equipotential lines. That's what it is. Always remember that. Okay. So that's what this diagram tells you. Now, When you are around a dipole, then it creates a field and potential. So this is positive, this is negative, you are separating it by some distance. From the center, you are at a distance of r, and together they will create a field, and that field will have two components. Look at this. This positive and negative together will create, let's say, this is the net field. The net field will have two components. One component is along that distance, that is called ER. Other component is perpendicular to that distance from the dipole to that point, that is E theta. What are the magnitudes of those components? The component which is along, keep this in mind, it is k, 1 by 4 pi epsilon naught is k, 2p cos theta by r cube, 2p cos theta by r cube. And the one which is perpendicular is just p sin theta by r cube. Keep this in mind. Okay, keep this in mind. Very good. Welcome aboard, Archana. Yes, Madan, the JEE crash course is available even right now. Definitely, I'll ask everyone, don't worry. Sir, I think P vector will be missing by 2A. No, Madan, it's up to you how you want to define P vector, as Q into 2A or Q into L, where L is the distance between the two charges. So that's what the major confusion happens. That's why, remember, D is the distance between the two charges. That way will be easier. And the potential, what is the formula for potential? K P cos theta by r cube. What is P? Dipole moment. 1 by 4 pi epsilon naught is 9 into 10 to the power 9. What is r? The distance. What is theta? The angle between the dipole and the point where you are trying to locate it. Angle between the point and the point where you are trying to locate the potential. Okay. Next important point. When you take a dipole and place it in somebody else's field, it will experience torque, it might rotate, it can, it experiences forces, like you can see. If this is a field, this is a dipole, the positive charge will get pushed here, the negative charge will get pushed here, that can create some torques, and that can also create potential energy. Okay, so when you try to rotate it, there is some work done by the field, so there is also some electrical energy associated over here. What is the torque? Torque is Pe sin theta. Torque is Pe sin theta. Very good, Sarvana. Oh my god, Archana, again you have a lot of people using different names, so difficult to remember each person's pseudonym, actual name and the screen name. My goodness. And yes, the potential energy is given by P dot E, which is P cos theta with a negative sign. Be careful. This is a dot product, so actually speaking it is minus Pe cos theta. Minus Pe cos theta. If I ask you, is there an angle for which the torque is 0? Is there an angle for which potential energy is 0? What will you fill over here? What is that angle for which the torque is 0? Come on. Gohan, what happens is, bacha, this negative charge will experience a force here. This positive charge will experience a force here. It will create a couple. So that's why there is a torque. So you will see whenever you take a dipole and place it in somebody else's field, that creates a coupled torque, and that is given by dipole moment. What is this P? This is your dipole moment. It's your dipole moment. And what is E, bacha? E is that external field. And what is this theta? Theta is the angle between the dipole and that electric field. So that is basically your theta. Okay, so yes, 0 or 180 degrees. Perfect. 0 or 180 degrees. And for what angle is the energy 0? Look at this formula. When is energy 0? Energy will be 0 when cos theta is 0. When is cos theta 0? When cos 90. Cos 90 is 0. So that means potential energy is 0 when the angle between dipole and the field is 90 degrees. They are perpendicular to each other. Perfecto. Perfecto. So why does potential energy come? So I think Kistu is asking, sir, please explain this concept. So I talked about the torque. See, whenever you have negative and positive charge and it creates a torque, think of it like a spring. You might have seen those watches where you have to turn it and it experiences some torque, like that spring action. So whenever you take this dipole and put it in somebody else's field, if you try to rotate, there is a torque because of the electric forces. So you find it difficult, and if you leave it, it will go back. If you turn it, the torque will push it back. So there is like some energy stored in that electrical system. So that's why there is this electrical energy. Okay, I hope that is clear. And this system will always try to align itself like this. It tries to align itself like this in the direction of the field, because the moment the dipole moment and electric field become parallel, then what happens? The force on the positive charge and the force on the negative charge will be collinear. They will be collinear, and there is no torque, there is no net force, and that's it. It will remain at equilibrium. It will remain at equilibrium. Is that clear now? Okay, very good. And it will be in fact stable equilibrium. It will try to stay there as it is. Even if you try to disturb it, it will try to come back. Okay, let's try to do this question. Okay, and we have this question: a given point charge at some distance from a dipole on its axis experiences force F. Now, if the distance of the charge from the dipole is doubled, then what is the new force acting on the charge? Come on, my warriors, think about it. Come on, my warriors, think. Yes, I think Risha. Yep, it is very easy. Board examination is easy, just that you should avoid your silly mistakes. That's all. Thank you for all the love, Priya. No, Prasad, taking a drop will not be a problem for resume or for placements unless you perform very bad. Okay, don't worry. This is a CBSE series, Kulappa. Okay, B, D, A. Many people are confused. Somebody is saying B, somebody is saying D. What will be the energy when the angle is 180, Talu? Simple. Use the formula minus PE cos 180. Cos 180 is minus 1. Minus 1 into minus plus 1. So it will be plus P. I hope that is clear. Well, most of you are wrong. Very few are correct. The correct answer is C. I think you missed. You did not read the formula correctly. The field formula due to a dipole had something like this K, then you had P, and then cos sine term, okay? And here you had R cube. Do you remember there was R cube below? And here in the question, what is mentioned? That the distance of the charge from a dipole is doubled. That means this R is made 2 times. If R is made 2 times, R cube will be made how many times? 8 times. 2 cube is 8. So the denominator increases by a factor of 8. The denominator increases by a factor of 8. So the field will become how many times? 1 by 8 times. And we all know that force is charge into field. So the field becomes 1 by 8 times. So the force will also become 1 by 8 times. Hence the answer is C. Understood? So there is square term when you have a point charge. Due to a point charge, it is inversely proportional to square. But due to a dipole, it is inversely proportional to cube of it. Keep this in mind. Many students make this mistake. Yes. Yep. So avoid this. It will save you those 4 marks. Imagine you will lose, not 4 marks, sorry, my bad, 0.77 marks. That's what board has come up with. And you will lose those marks. I'm pretty sure you don't want to lose that. A dipole in external uniform electric field, which is not true. If you take a dipole and place it in external uniform electric field, which of the following is not true? It will experience no net force, it will experience no net torque, may experience net torque, none of the above. Very interesting question. So Karuna Murthy, if you have not studied 4 lessons in physics, I'll tell you a very simple trick. There is a playlist of mine. Watch those classes, you will understand it. Okay? It will not take you more than maybe 6 hours. Even that 6 hours is very beneficial. Okay? But don't study all the 4 lessons. Watch my strategy session. I have told which lessons you can skip and still get full marks. And you can still get maximum marks. So just watch my strategy session and accordingly only watch those playlists. Is that fine? Okay, many of you are saying B. Yes, it is correct. B is correct. So whenever you take a dipole and place it in external field, and if the dipole is like this, then the torque is obviously 0. But if you place the dipole something like this and the field is over here, then obviously the torque is not 0. In any case, The force on the negative, force on the positive, force on the positive, force on the negative. The net force will be always 0 because the positive and the negative forces will cancel each other. What will they do? They will cancel each other. That's the reason why net force will always be 0. Will experience no net force? Yes, that is true. But remember, the question asked was which is not true. This is true. Will experience no net torque? You can see it experiences torque. That is wrong. May experience net torque? Yes. Do you understand the difference between will and may? Do you understand the difference between will and may? Will means it is always true. May means it may be true, possibility. Chances are there it is true. Sometimes it might not be true. So understand the difference. Perfecto. Perfecto. Let's move on to the next one. Yep, he can also watch it at 2x speed. Very true. So, Salva Kavantan, it's going to last for more than 2 hours for sure. Mrudu, join in, trust us, watch the complete class, do whatever I have told in the strategy session few days back, watch the playlist, that's it, and stay tuned even before the JEE and even the board's attempt. And trust me, whatever we do, just follow it. You will get lots and lots of mark. You will come back telling, after the board examination, sir, I scored very good. Even in these last few days. Trust me, things can change. So flux. What is flux? Flux is the flow of something. Electric flux means flow of electricity, electric field lines. And how do you measure flux? Flux has to be measured when it passes through an area. And it depends on the field, the angle and the area. So the formula for flux, remember the symbol is phi, is given by electric field into area into cos theta. Perfecto. Oh my god, Rishabh says Pomodoro technique is very effective. Good to know that. Very good. Glad. Follow other techniques also, the 5i technique, the time quadrant technique. So many techniques I have given in the strategy session. Now, sir, will the force not be 0 at any situation? It will be 0 in all the situations. Okay, it will be 0 in all the situations. Okay, so electric flux is proportional to the number of field lines. Yes, more the field lines, more the flux. Now imagine if there is an area and the area vector is a vector which is perpendicular to the surface, and you find that your electric field lines are going like this. You will see nothing is piercing through, then the flux will be 0 because the angle will be 90 degrees. Angle is 90, cos 90, 0. So flux is 0. That's how this works. That's how flux is calculated. Now based on the flux, you have something called as the Gauss's law. And what is Gauss's law? It is nothing but, let's quickly revise. If you have certain charges, Q1, okay, Q2, then Q3, and then let's say Q4, okay, and let's say you draw a closed surface which encloses some charges. So this is a closed surface. Each charge will give some field. This charge will give some field at this point, this charge will give some field, this charge will give some field. So there will be a net field. Even this charge will give some field. All the charges will give some net electric field. This closed surface, you divide it into small areas. Each elementary area, I will call it dA. What do I call it? dA, elementary area. Then when I calculate the flux through that, the flux through this, it will be E vector dot dA. It will be the flux through that small area. Now when you do the total flux, so the total flux through the closed surface, so the flux through the closed surface means net flux, that means integration, adding up flux here, you have divided, remember, into small areas. And you do this, what do you get? Basically, you will get this answer as Q, which is inside by epsilon naught. Now, remember, d phi itself is nothing but E vector dot dA vector. This is nothing but called as the Gauss's law. So, in this situation, the enclosed charges are this, this and this. Q3 is positive, Q2 is negative, Q4 is also negative. So, this part is only the charges which are inside that closed surface. Who will decide the closed surface? You will decide. How will you decide? As per the convenience. See the geometry. If it's a point, sphere, choose a sphere. If it's a line, cylinder, choose a cylinder. If it's a sheet, choose rectangular cuboids or cubes, something like that. So choose a convenient Gaussian surface. What is epsilon naught? Prasad, don't you think it's a little bit too late to ask that? But anyways, it is permittivity of free space. It's permittivity of, yeah. Yes, Challenger man, I'll be doing the one shot for the other chapters, the magnetism till EMI AC tomorrow, okay, at 6:30. Moving on to the next question, coming up on your screen. Okay, so yes, Vaideshwari, even if you have not started reading physics, at least you'll get some marks watching these sessions, I can assure you that. Follow the strategies I gave you, watch my playlist and follow my sessions, you will at least get some marks. That's something that I can tell you for sure. 3 points, and also watch my sample paper solution. I have solved the sample paper, watch that also. 3-point charges are located at these coordinates. What is the total electric flux over a sphere of 5 meter radius with center as 0, 0? Very interesting question. Let's see. Come on, my warriors. I will be giving tips for KVPY maybe after the board exam is over, because now you are all interested in the boards. After that, definitely I'll come up with strategy sessions for all of you. Don't worry about it. Okay, so what do you guys say? What is it? In which channel? This channel, Sarvana, the channel which you are watching right now. In Enthuse channel only, all my playlists are there. Just go to playlist. Okay? Let's see how many of you can do this. Come on, my warriors. So let's just draw a diagram. Okay, probably things will be very, very clear. So X, Y, Z axis, and imagine a sphere of 5 meter radius. So 5 meter radius, this is my sphere. Okay, sphere of radius is equal to 5 meters. Now, if you look at all the charges, Q1 is at origin. Okay, this is Q1. Q2 is basically at 3, 0. Okay, 3, 0 is obviously within the radius. So this is where Q2 is. Q3 is at 0, 4. So this is where Q3 is. Q3 is 0, 4. Okay, it's all within the sphere. So all of them are enclosed. So all charges are basically enclosed. Now if all the charges are enclosed, the question is, what is the total flux of the sphere? Using Gauss law, using the Gauss's law, what will you get? The total flux is Q in divided by epsilon naught, correct? So what is the total electric flux? I think the units are a bit of a problem. I think there is one epsilon naught missing. I'll just do the math and I'll tell you. See, just add the charges. Q1 is 5, Q2 is 4. So 5 plus 4 minus 6 divided by epsilon naught. 5 plus 4, 9, 9 minus 6 is 3. So 3 by epsilon naught, but that's all in coulombs. So yes, so I think the units should have been different. It should not be coulomb. So that's one mistake, printing mistake. So ignore that. So what is epsilon naught? Epsilon naught is 8.85 into 10 to the power 12. So you can almost take this as 9. Okay, so 3 by 9 is like 1 by 3. So 1 by 3. Come on, guys. It is almost going to be like 3 into 10 to the power 8 minus 8 or something. Yep, just check this out. If you guys have got it, perfecto, 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 excelente, excelente. Let's move on to the next one. Yep. So this is a very easy question, but many students will make some mistake in calculations. The electric field in the region is given by 50 Newton per Coulomb I cap. That means it's in the x direction. Look at the cylinder. Cylinder's axis is also the x-axis. The question is, find the net flux through the cylinder of radius 1 meter and length 2 meters. Very interesting. I think, Baladitya, that probably that power could be a problem. Let me just see if there was any error in that particular thing. Okay, I'll get it changed. SPS. All right. What's the difference between flux passing through a cube and a window-like thing? So, Thai, I think now you will understand the difference. exactly through this question. Observe it. Observe it. Okay, come on my warriors. Let's see how many of you can do this. The flux passing through a cube and a window-like structure, you'll understand the difference exactly in this question. This is a complete cylinder. Well, many of you are saying A and B. Okay, the correct answer is actually B. Now I'll tell you why the answer is B. See, this is a uniform field. First of all, understand that. This is uniform electric field. That means whatever lines come inside will also exit out. So, what is the total flux? If you can see the flux is coming out here, and if I take it as positive, here it is going in and it is negative. The number of lines coming in is equal to the number of lines going out. Hence, the total flux basically is going to be 0. So, understand, when I take a cube-like object and let's say for example, the field lines which are coming in and going out are same, then what happens is basically the net flux will become 0. But through any one surface, that flux is basically non-zero. There is flux through each surface, but as a whole, because it's a closed surface, then the lines coming in and going out might not be the same. Yep, I hope this is clear. Yeah, option C is not correct, option A is not correct, option D is not correct. If the question said what's the flux entering through this surface or entering or passing through any one of the circular bases, then your answer will be pi r square into the field. That's when you will get pi r square into E. Understood, my warriors? Be careful. Okay, and r is 1, so we can just do the math. Yep. Okay, yes, r was 1 and pi is pi, so that's it, and field was 50, so I think you will get 50 pi. Correct, Sarvana? Okay, what resource should you follow? My playlist and exemplar. Watch my strategy session. I have mentioned everything. What resources? Exactly what you asked, Selva Mankatan. Okay, exactly the same question I have answered in detail, in my strategy session for CBSE board examination, just conducted few days back. If this is the electric flux which is entering and leaving a closed surface, and that is given by phi1 and phi2 respectively. Entering in is phi1, exiting out is phi2. Then the electric charge inside the surface will be given by which of the following formulas? Okay. Yep, Varshita, in my Pathfinder playlist, I have taught the entire chapter in detail along with solved problems, along with questions, advanced problems, theory, everything in my playlist. It's there on this channel itself. So let's see how to solve this. Remember, by Gauss's law, the net flux is the enclosed charge by epsilon naught. Now net flux, so the charge which is entering in will be, okay, the one which is entering in will be negative. The charge which is leaving out will always be, the flux which is leaving out will always be positive. So entering in is negative and exiting out is positive. This is Q in by epsilon naught. So Q in will be, take that epsilon naught here, and phi2 minus phi1. That should be the answer. Is it there somewhere? Yes, option A. Option A. No, it is not C, it is option A. Be careful. The only difference is one is the sign and the second thing is epsilon naught is above or at the bottom. Be careful. The question was not the flux, the question was how much is the charge. So you have to take the epsilon naught on the top. A lot of students make that mistake. Perfecto. Amazing. Go. Moving on to the next question coming up on your screen. Let's see how many of you can do this. What is the total flux associated with the cube where A is the side of the cube? Then, what do you think is the total flux going to be dependent on? This is a cube. Charges are there at the vertices. Do you think it will depend on the order? Order means, have you placed 2 here or here? Have you placed 2, 1, then 4, then 2, or 1, then 4, then 3, or 1, 3, 4? Does it depend on that order? Or does it depend on the magnitude? Does it depend on which charges are there inside the cube surfaces? Does it depend on the size of the cube? What do you think? Okay, what is the answer? Come on, my warriors. Interesting question in front of your screen. Does it depend on the order? Second says it will not depend on the magnitude. Third says it will depend on which charges are inside. Come on, think. I feel it is very easy. Okay. Magnitude means modulus, Sarvanan. Watch my lecture on vectors also. Magnitude means modulus, the length of a vector. Now, magnitudes are there with scalars also, vectors also. For scalar it is simple. I walked 5 kilometers. 5 is the magnitude. The force is of 10 Newton I cap. 10 is the magnitude. That's all. So magnitude of the charges. Okay, so let's see. The correct answer is C. It will depend on which is inside, which is outside. This is completely dependent on Gauss's law. That's what Gauss's law is, right? The Gauss law, what does it say? The total flux is basically Q in by epsilon naught. So the inside charges matter. So this is, it will not depend on the magnitude. That is wrong. Obviously it will depend. Will depend on the order. How does it depend on the order? As long as it is inside, it doesn't matter. Doesn't matter where it is placed. Once you're inside, the order does not matter. Depends on the size of the cube. How will it depend on the size of the cube? Whether it is a big cube or a small cube, if all the charges are on the vertices, the charges will also move with the vertices. So it won't change it. So answer C is correct. Yeah, great. Now formulas for field due to different geometries. I am giving you the sheet over here, and this sheet has basically electric field on this side and the other side. It's a uniform field which is created. What's the formula? Sigma by 2 epsilon naught. So whenever you have a charged sheet, it creates electric field this side and this side, and because it gets divided into 2, that's why this half factor comes. It's 1 by 2 sigma by epsilon naught. What is sigma? It is the charge per unit area. It is also called as the surface charge. What is it called? Surface charge density. How much charge is there if you take 1 unit area? How much coulombs is there per unit area? So sigma by epsilon naught into half. Next important formula, you have a line, you have a wire which is uniformly charged. And what is lambda? What is lambda? Lambda is nothing but linear charge density. Linear charge density. And what's the unit of it? It is nothing but coulomb per meter. This line charge will create electric field around it somewhat like this, and as you go away, the field changes by this formula. Lambda divided by R into 1 by 2 pi epsilon naught. Some people also like to remember this as K into lambda by R, but remember K is 1 by 4 pi epsilon naught. So you just multiply it by 2. So that 2 from the top and 4 from below, only one of the two will remain. So 2K into lambda by R, one and the same thing. Okay. So as R increases, you will see the field will decrease. So if R increases, field will decrease. That's what will happen. Next important formula, what is it? Yep. So but when the size increases, area will increase. I'm not sure which point you are talking about. The size increases, the area will increase. Oh, for the previous one? Okay. So what will happen when the size increases? Area will increase, but the field will also reduce because the distance has increased. So it will compensate for it and the total flux will remain same. The better way to approach it is not via area but via Gauss's law, because the total charge enclosed will still remain the same. Doesn't matter how big the cube size was. Okay. I hope that is clear. SPS, yep, I think I just answered it. So when you have a shell, remember the field inside is always 0. When you have a shell, there is no field inside. The field is only there outside, and when you are outside, it behaves like a point charge. Yes, a shell behaves like a point, and what is the field due to a point? It is just K, this 1 by 4 pi epsilon naught, Q divided by R square. So KQ by R square is the formula, but when you are inside, the field is always 0, and on the surface, just put the value of small r as the radius. You will get the same thing, one and the same thing. Similarly, when you have a uniformly charged solid non-conducting sphere, so uniformly charged sphere means the charges are there inside, it's completely filled here, uniformly filled. Then the field inside is not zero. In fact, it is proportional to R, and then once you go outside, it again behaves like a point charge. And that's what you can see. When you are outside, it is just kq by r square. You can see it is kq by r square. But actually when you are inside, it is kq small r divided by r cube. Now this is the formula when you are inside, okay? So keep this formula in mind. This is also the same thing in case if you want to remember it the other way. kq small r divided by r cube, you can see it is proportional to r and then inversely proportional to r cube. This is what it is for a solid uniformly charged sphere. Okay, let's start solving some questions. Come on, my warriors. Yep. Sarvana, I would say the fields cancel out at the center rather than charges cancel out, because charges don't actually cancel out, it's the field due to them which cancels out. Glad to know, Mara, you're enjoying it and doing your quick revision just before the boards, always for all of you. Okay, but the electric field due to the shells are deleted for CBSE. Is it? I don't think so. Maybe there could be some easy questions. Okay, doesn't matter. We just did it. Just do this now. An infinite line charge produces a field of 9 into 10 to the power 4 Newton per Coulomb at a distance of 2 centimeters. What is the linear charge density? It is the linear charge density. Come on, come on, come on, come on. Let's see how many of you can solve this. Linear charge density. We have a line which is charged, and the question says if you are at a distance of 2 centimeters, then the field value is given to be 9 into 10 to the power 4 Newton per Coulomb. What is the linear charge density? Come on, come on, come on, my warriors. Think carefully. What will it be? Okay, I think which formula should we use? Or standard formula for field due to a line charge, which is lambda by 2 pi epsilon naught into r, which I just told you is nothing but 2k lambda by r. So field is given 9 into 10 to the power 4, 2 into k, k is 9 into 10 to the power 9, lambda I don't know, r is 2 centimeters, so 2 into 10 to the power minus 2. Let's see what and all gets cancelled. This 9 gets cancelled, this 2 gets cancelled. 10 to the power minus 2, when it goes on the top, it will become 10 to the power 11. 10 to the power 9 and 10 to the power 2 will become 10 to the power 11. This 10 to the power 4 will go, and this will become 10 to the power 7. So basically I'll get lambda is equal to, bring this guy over here, 10 to the power minus 7 Coulomb per meter, which is 10 to the power minus 7 Coulomb per meter. We can just leave it like that. Yeah, that's it. Nothing else is remaining. Cool. So 10 to the power minus 7 Coulomb per meter should be the answer. Yep. How many of you got it? Perfecto. Yep. Perfecto. Very good. Very good. So yes, 10 microcoulombs per meter. Okay. Moving on to the next question. Yeah. So how will the graph of electric field and potential due to a charge conductor look like? How will the graph? Yep. How will the graph look like? Think. Yes. Do you remember how will the graph of electric field and electric potential look like due to a charge conductor? This is a charge conductor. Come on, let's see how many of you can get this. Very easy question. You might be given some graphs. Are you able to draw it? And then obviously you cannot post the answer in the comment section. So I'm just giving you the time to roughly draw it in your rough notebook, and probably then you can verify it. So first of all, let's talk about the field versus the distance. So the graph of field for a charged conductor like this. Remember, since it's a conductor, the charges will be only there on the periphery. It will not be there anywhere else apart from the periphery. So this, although it is a solid conductor, it behaves like a shell. And the moment it behaves like a shell, it becomes very easy. I know the field inside is 0. So it is nothing till the radius r. So till the radius r there is no field, but the moment you go up outside, then it is inversely proportional to r square. So that's what it is. That's the field. Next, after solving the field problem, let's look at the potential versus distance. Remember, potential can be found out like this. Remember, E is magnitude wise dV by dr. So if E is 0, then dV by dr is also 0. That means V is constant. A lot of people think inside field is 0, potential is 0. No, inside field is 0, rate of change of potential is 0. So in fact, potential remains constant throughout, and once you go outside, it becomes again inversely proportional to R. That's it. So till you reach the surface, it is a constant value. Keep this in mind. A lot of people make that mistake of marking it as 0. Okay, so that's the graph of potential. Some of the very important properties of conductor, what are they? Number one, obviously the charges are always on the surface. They do not go inside the solid part of the conductor. When they stay in equilibrium, they are always on the surface of the conductor. Also, the field inside the conductor is always 0. The field, because there is no charge, there is no field inside a conductor. The fields are always outside the conductor and they start from the surface perpendicular to it. That's very important. Okay. Similarly, you can have some more properties which I have listed over here. Some more important properties will be, if you place a charge inside a cavity, that can create induced charges over here. That can create induced charges in the inner surface of that conductor, of that cavity. Similarly, you can see the shape of the conductor also redistributes the charges on the conductor. That means wherever you see a sharp edge, you will see more charges over there. Keep this in mind. Whenever the conductor is sharp, there are more charges, and wherever it is not sharp, it is blunt, you will have less charges per unit area. Keep that in mind. Okay, very, very important pointer. Let's see how many of you can solve this question now. Here we have a diagram of a random shaped charged conductor, and there are 4 locations on the surface: A, B, C and D. For these locations, in the increasing order of the strength of the electric field, right from the smallest to the largest, what do you think is the correct order of the electric field? Yes, the positive charges on the surface will also exert field around it, but the net field inside will be 0. Okay, so Sarvana saying A more than D more than C more than D. Interesting. Let's start from the smallest. Starting from the smallest. Which is the most flat surface or the blunt surface? I can see this B surface is the flattest surface. So here the charges will be very less. Here I know it will be the most because it's very sharp. C is like okay types. Okay. And D will have little bit more. Okay. So that means the field at B will be the least, at C will be slightly more, at D will be even more, and at A will be the highest. So that will be the increasing order B, C, D, A. Correcto. Let's see how many of you got it. Perfect. B, C, D, A. Excellent. Excellent, Ashika. Very good. Very good. Selva. Very good. I can see many of you have got it. Excellent. So let's move on to the next one. And here it is. For a positively charged solid conductor, the potential is maximum at, where do you think it is maximum? For a positively charged conductor, is it maximum at the center of the mass? Is it maximum at the infinity? Is it maximum at the surface? Or it depends on what geometry are we talking about? Come on, think. Visualize some conductor. Think about where will the potential be maximum? Max center, surface, infinity, or does it depend on the shape, size, etc.? Okay, some of you are saying A, some of you are saying C, one person saying D, okay, one person also saying B. Okay, the correct answer is actually on the surface. Another reason for that is simple, I'll tell you. If you have any random shaped conductor, first of all, the charges will be only on the surface. Correct? The surface will only have the charges, nowhere else. That means the field lines will only originate from here. Okay, the field lines will only originate from here. Now where does field go from? Field always goes from high potential to low potential. The question is, where is the potential maximum? So the potential will be maximum here. Now I'll be like, sir, what about here? Think all these points have no field. In fact, the potential is constant over here. There is no field inside. So in fact, the potential is maximum on the surface and it stays there throughout the solid. Hence, the answer is on the surface, not center of mass or anything. Let me tell you, if you want the entire PDF, you can get it right from our Telegram channel, link which is there in the description box below. Do not forget to join our Telegram channel ASAP, because not just the PDFs, but you also get so many other updates instantaneously, like a sudden lecture or some sudden announcement always comes up over there. Okay, so what's the difference between a shell and a solid conductor? There is no difference, Yogal Shalmi, from the point of view of electrostatics. Because for a solid conductor, the charges eventually come on the surface, so it ends up behaving like a shell only. But if it's a solid non-conductor, then the charges cannot come on the surface. So that's why the formulas for non-conducting or insulating solid sphere are different than from solid conductor. I hope that makes sense. Yep. So if the charges are held together near any sharp points, won't they repel each other? Yes, but they have nowhere to go because there are charges elsewhere also. And that's the reason why, they cannot move, and the chapter's name is Electrostatics. And remember, the charges have to stay in such a way so that the net electric field inside the conductor has to cancel out each other. So they will arrange themselves accordingly. They'll try to go away as far as possible. Okay, shall we go to capacitors and capacitance? Ready to start solving questions on capacitors? Do you remember these formulas? Charges, capacitance into voltage. What is a capacitor? Let's see how many of you can remember it. What's a capacitor? Capacitor is basically, what is it? It's nothing but any device which can store charge in the form of electrical energy. It stores energy in the form of when these charges get accumulated on the conductors, and that energy is in the form of electrical energy. And the charge stored is dependent on the capacitance and how much voltage you apply between those two conductors. And that is given by C into V. That's it. Fair enough. That's the symbol. The plates store the charges. They are oppositely charged. Next, energy stored, because like I just told you, it stores energy. You can remember any of those formulas. Most of the times, half CV square and half Q square by C are very useful. Remember it. Half CV square is the energy stored in a capacitor, or half Q square by C. Keep this in mind. Yep. Okay. Let's see how many of you know this question's answer. The electrostatic capacitance depends on. So basically the capacitance depends on what particular thing. Is it nature of the conductor? That means whether it is made of iron, whether it is made of aluminium, or does it depend on the size of the conductor? Does it depend on the thickness of the conductor, or none of this? Let's see how many of you know this answer. It's going to be a very interesting one. Well. The correct answer is option B. Many of you made a mistake out there. See, whenever I take a conductor here and conductor here, okay, whether it is made of iron, whether it is made of copper, whether it is made of aluminium, doesn't matter. What matters is, what is the size of this? What is the distance between them? That's what matters. Thickness of the conductor does not matter, because even if the conductor is thick, the charges are going to stick here only. If these are the plates of the capacitor, how does it matter? What is the thickness? This is the thickness of the conductor. This has no role to play in the field which is created between the plates of a capacitor. So the distance between the plates matters, but the thickness of the plates does not matter. A lot of people get confused between thickness of the conductor and distance between the plates. Keep this in mind. Okay, so I hope this question has enlightened you. If you take 100 joules of work, and that is the joules of work done by a battery in charging a capacitor. So this battery has charged this capacitor by doing 100 joules of work. Then how much energy do you think will get stored? What is a battery? Electromotive force. It does some work to transfer the charge from negative to positive terminal. So think, if it does 100 joules, how much energy gets stored into the capacitor? Yep. So yes, Ishwar, when dielectric is filled, then the thickness of the dielectric matters. Thickness of the conductor never matters. Here. So be careful with the words. Gopika saying C, Renu saying A, Acha saying C, How saying A, Meghavarshini saying C, aggressive Ajay saying C. Oh my God. Let's have a look at this. First of all, remember this rule, 50-50 rule. Everybody might have heard about that 50-50 Maska Chaska biscuit. So 50-50 rule. Remember, if 100 joules of energy is used by the battery, or rather battery does 100 joules of work, then 50% goes in the capacitor, 50% basically goes in the resistor in the form of heat loss. This is only getting stored. Half the energy gets wasted. So the answer is 50 joules is stored in the capacitor and 50 joules is basically lost. Keep this in mind, 50-50 rule. Okay, option C, 100 joules is not stored in it. Okay, moving on to the next one, the formulas for capacitors. Parallel plate, cylindrical and spherical. So if you have two plates parallel to each other of area A and distance D, the formula for capacitance is epsilon naught, which is permittivity, into area divided by distance. If you feed in some masala, like this is a sandwich, you have to think of this like the bread, you add some cucumber, you add some tomatoes, you add some sauce, then this comes in onto place. This is called as your dielectric constant. Okay, so this is your dielectric constant or relative permittivity, and this will increase your capacitance. When you add masala, it increases the capacitance. Keep that in mind. Okay. Now formula for if there is no resistance, Guhan, then the wires will also have resistance. The wires will lose that energy. Okay, so it's not possible to have an ideal circuit. Each wire will have some milliohm at least resistance, so that resistance will lose that energy. Keep that in mind. Okay, now yes, it depends on the nature of the material which is filled between the plates, not the material of the plates. Understand the difference between material of the plates means the conducting material. Between the plates, that means the gap is filled with wool, glass, water. That decides your relative permittivity. Understand the difference. Okay, for spherical capacitor, what is the formula? 4 pi epsilon naught. You can remember this, or another way is remember it like this: 4 pi epsilon naught 1 by A minus 1 by B. That's it. It's the same thing. You take the LCM and shift it, you get this as the answer. So 1 by A minus 1 by B. And when you have a cylindrical capacitor, see, in spherical capacitor what happened? Charges are there here and on the outside, and there is a gap. So charges are storing the energy in the region between those two shells. Here the energy is stored between these two cylinders. This is positive, this is negative. You can see there is field between these two shells or these two cylindrical shells. Then the formula is 2 pi epsilon naught, length of the cylinder divided by log of bigger radius by smaller radius. Ln is log. Okay, chalo. Let's move on to some questions coming up on your screen. Oh my God, Rishabh, you are seeing this for the first time. I hope now this will not be the last time. You have to write it down in your notes now. Okay, chalo. Let's do this. Okay. So Abhishek, we are following basically, JEE syllabus kind of thing. Eventually all the chapters, be it chapter 9th, be it chapter 8th, everything will be covered. So I don't know which is your chapter 9th in your book. So you can probably tell me, I'll tell you when it will approximately come. Aggressive Ajay, you can read the thumbnail and the description box. All the chapters mentioned here are going to be discussed. Okay, Sarvan is saying B, Ishwar saying A. Well, for a charged capacitor connected to a battery, if the distance between the plates is reduced, then which will decrease? The correct answer is none of these. Oops, none of you got it. None of these. Okay, so I'll tell you what it is. See, when you take a capacitor and connect it to a battery, okay, then doesn't matter even if you change the distance between the plates. Okay, this is the distance between the plates. The voltage is going to remain constant because the voltage is going to be E only. And we all know Q is equal to CV, and C is nothing but epsilon naught A by D. V is as it is. This is the charge. Now think, if you reduce D, V is anyways a constant, then what will happen? The charge will obviously increase. Can you see that? So definitely, then which will decrease, pucha hai? So the question asks is which one will decrease. So obviously the charge will decrease, and this, when D decreases, you can see capacitance also increases. So capacitance is increasing, voltage is basically constant. And what is the formula for energy? Energy, the formula is half C V square. Now you can see that voltage is constant, capacitance is increasing, so energy is also going to increase. So none of these quantities are going to decrease, hence the answer is none of these. Understood how to use formulas? These kind of questions can come in the examination. Abhishek, I will do properties of fluids probably in the month of January. Okay, this month we are going to spend time with SHM, then we'll start fluids. Okay, so once fluids is done, then you will see properties of material. Matlab that is going to follow after that. Okay, what to do to remember these formulas? Karuna, solve substitution based questions. Okay, just substitution based questions, solve many questions, then you will remember these formulas. Okay, what is the capacitance of a conducting sphere of radius r? Come on, think. What is the what is the capacitance of a conducting sphere of certain radius r? Very interesting question. So those of you who have attended my classes know how to solve these questions. If you have a sphere of radius r, it is also like a spherical capacitor. We just saw the formula for a spherical capacitor is 4 pi epsilon naught 1 by A minus 1 by B. Now you'll be like, sir, there is only one shell here. Where is the other shell? Guys, the other shell is nothing but infinity. So yeah, you can think of the other shell as infinity, and that makes the problem simple. So this will become 4 by epsilon naught 1 by A is nothing but R, minus 1 by infinity. What is 1 by infinity? 1 by a very large number is 0. So that means what will you get? See over here, 4 pi epsilon naught. This is 0, so we'll just get 1 by R. So it will become 4 pi epsilon naught R. So that's the answer for capacitance. Perfecto, Selva. Okay, cool, very interesting. Okay, so that's how you can find out, and you should mark that answer. Options will be like 4 pi epsilon naught, 2 pi epsilon naught r, 8 pi epsilon naught r. You are going to mark 4 pi epsilon naught r. Moving on. In the capacitor of capacitance 20 microfarad, the distance between the plates is 2 millimeters. If you add some material of dielectric constant 2 is there between the plates, then the new capacitance will be what? Come on, think. Is it 20? Is it 30? Is it 10? Is it 40? Figure this out. What do you think will happen? What will be the new capacitance when you add some new material between these two plates of the capacitor? Rishabh saying D, Ratna saying D, Ashika saying D, Zeph also saying, oh, Zeph saying, yep, D. I think you guys are correct. Perfecto. Like I told you before, capacitance is, epsilon naught A, okay, epsilon naught A divided by D, and you always have that dielectric constant here. So if this K is basically equal to 2, so basically the capacitance will become 2 times the previous value. So if earlier it was 20 microfarad, now it will become 2 times more, which is 40 microfarad. Perfecto. Now, you should know that when you have capacitors in series and parallel, the formulas for finding equivalent capacitance is exactly opposite to that of resistances. So when in series, you will use 1 by C1 plus 1 by C2 plus 1 by C3 is 1 by C effective. And when capacitors are in parallel, okay, when they are in parallel, then the effective capacitance will be C1 plus C2 plus C3. Okay. In case of capacitors in series, is the charge same or voltage same? Come on, think about it. Come on, think about it. Yes, Tattva is definitely helpful for term 1 as well, but do only exercise 1 Zeph. Babu, like I mentioned, I'll be doing it in December end or January, okay? Yeah. So, charge is same, correct. And voltages are different. But when capacitors are in parallel, the charge gets distributed, Q1, Q2, Q3, and the voltage is same across all of them. Okay? That's it. As simple as that. Moving on to some questions. Question is to find out what is the equivalent capacitance between these 2 points A and B. Very interesting and easy question. Let's see how many of you can do this before me. So, these 3 capacitors are in parallel. So, if they are in parallel, what will you do? Add the capacitance C plus C plus C, which will give me 3C. Now, this 3C and this C, this 3C and this C, basically they are in series. So, you are going to use 3C into C divided by 3C plus C. Basically, see this, 1 by C effective is 1 by C1 plus 1 by C2. If you take LCM, right, it will become C2 plus C1 divided by C1 C2. So that is 1 by C effective. That means C effective will be C1 C2 by C1 plus C2. So that's the formula that I'm using over here. So it will become 3C by 4. That's the answer. Perfecto. Let's make it slightly more difficult. 3C by 4 was the answer. Moving on, next question. Let's see how many of you can do this. Come on, my warriors. What is the correct option? 1, 2, 3, and this is the 4th capacitor. You can see the wires connected as follows. Figure this out. I'll give a hint. Mark the potentials. It will become very, very easy. If this is point A, this is also having potential A because this is a wire. This is the same wire continued. So this is also having potential A. If this is B, this is also B, and this is also B. That's it. I think I have figured out what the equivalent circuit looks like. So I have this point A, and between A and B I have one capacitor. Okay, so I'll just probably draw B over here. Between A and B I have this one capacitor, this one, and between A and B you can see 1, 2, 3 capacitors, one after the other. So I have 1, 2 and 3 capacitors, one after the other. So this is the equivalent circuit. Now you can solve this very easily. These 3 are basically in series. So 1 by C plus 1 by C plus 1 by C, which is 3 by C, is 1 by C effective. So C effective is C by 3. If this is C by 3 and this is C, both of them are in parallel. So this and this C by 3 are basically in parallel. So just add them. So C plus C by 3 is basically 4C by 3. Where is it? Option B. Perfecto. No, it's not 5C by 3, it is 4C by 3B. Little bit careful. Okay, moving on to the next one. Okay, come on my warriors, let's go to the next one. Very interesting. Find the equivalent. Yes, Selva, even I hope. Find the equivalent capacitance between the points A and B in this circuit. This is also a very common circuit. It can be asked in your board examinations, and this is just again by the method of potentials, you can just get it. See, I'll tell you what you should do again. If this is point B, this is also point B. If this is point B, this is also point B. Achha, if this is A, this is also point A. Achha, this is some new point, let's say I call it point D. Start drawing the circuit. Start from A. When you start from, let's say I'll start from B. B is very easy. So let's say I start from B. I get one capacitor here, and I also get one capacitor here between B and D. Okay, so when I start from B and I go till D, okay, so this is B and this is D, I get two capacitors between B and D. Can you see that? Which are the two capacitors? These are the two capacitors, BD, BD. Fair enough. Now from D to A, I get one capacitor. So from D to A, I get one capacitor, and this is that one. Lastly, I forgot only this one capacitor, and that is between A and B. You can see that it is between A and B. So this is between A and B. That's it. So this is the equivalent diagram. Now you try to solve this. It's very easy. These two are in parallel. So C plus C, that is 2C. These two are in series. These two are in series. So when they are in series, what will happen? It will become 2C into C divided by 2C plus C. So it will become 2C by 3. So now that 2C by 3 and this capacitance are in parallel. So 2C by 3 is in parallel with this C. So just add them. So the equivalent will be 2C by 3 plus this C. So 3 plus 2, 5. 5C by 3. That's the answer. Perfecto Cholan, perfecto Ashika. Very good Rishabh. Very good, very good, very good. Moving on to the next one. 5C by 3 is the answer. Very interesting assertion reason question. Assertion says when you have a circuit, when two capacitors with capacitances C1 and C2 are connected in series with C1 followed by C2, there is a slab which you put here. The current starts flowing for some time. The slab changes the capacitance of C2 and hence the charge distribution occurs. What do you think? Are both of them correct? Both of them wrong? Are they correct explanation of each other? Or what do you think? Yes, potential method is fun. Very true. You just have to figure out the disguised form. Okay, hello Chandran ji. Welcome aboard. Priya saying A. She feels that both the statements are correct and they are the correct reasons for each other. I don't know. Sholan also saying A. Interestingo. Come on, my warriors. What do you think? Figure this out. What do you think is the correct reason? Is it wrong? Come on, figure this out. Well. I have a feeling. Okay, I have a feeling many of you made a mistake, and let's find this out. See, when you add capacitance, when you add this dielectric slab, so that slab is basically a dielectric medium. It will obviously affect the capacitance. And the moment the capacitance gets affected, what will happen next? The moment the capacitance gets affected, what will happen? The voltage will change, the charges will change. So the capacitance will change the voltage. It will also affect the charges. So, and the moment the charges on it changes, so if the charge on this changes, obviously that will create a current in the circuit. That will obviously create a current in the circuit. So hence, the moment you add a slab, what happens? A current will flow because the capacitance changes. Capacitance changes, Q will change. Q is CV. So that's the reason why you will see current, and that current has been caused because of the change in the charge distribution. So yes, both the statements are correct, and the reason is also the correct explanation of the assertion. Option A. Some of you got it. No, Ramya, right now I'm in Bangalore. Okay. Are you now ready for the next chapter revision? Current, electricity. Sir, what is the charge flow between the capacitors? So the charge flow between the capacitors means, where is it? Was it mentioned? The charge is, oh, where is it? Current flows in the circuit for some time. That's it. So between the capacitors means it will, if this charge changes, this charge will also change. There will be some current between these two capacitors. That's it. As simple as that, Priya Siva. Okay, cool. Ready? Okay. Oh, and by the way, there is also a very important announcement before I move on to current, electricity, and that is, if you want to take up more mock tests, and if you want, just before every examination, be it maths, bio, chemistry, physics, you want to revise all the chapters, and that too chapter wise. Electrostatics separate, or you just want to revise current, electricity, or you want to revise EMI, or you want to revise magnetism. There are going to be sessions which are going to be conducted on our Vedantu platform for free of cost. So if you are a pro user, it's for free. Make sure you attend those just before your examination. So the moment maths is over, sessions for physics will start. Moment physics is over, sessions for chemistry will start. Moment chemistry is over, sessions for bio will start. The math sessions will start soon. So do not miss this opportunity where you are going to get the complete revision to be done. It's only there in the pro subscription for free of cost. Quickly, let's move on to the next one, and that's current electricity. Remember, the climate is very cold, and that's the reason why I'm wearing this jacket. I wish it becomes a little bit warm soon. Okay, definitely Sarvana, you will be benefited, definitely, but you'll have to revise the chapter after this. It's not like you just attend this class and you are going to get full marks. You have to definitely make your effort too. Yep. Yes, Rishabh, the potential method will also be useful for resistors as well. So, first of the few formulas, what is current? Current is nothing but the flow of charges per unit time. And the current per unit area which flows through a wire is called as current which flows per unit area. How much current is packed in a unit area is called as current density. Correct. And the electrons, if they flow in one direction, well, that's negative charge. The current convention wise is in the opposite direction, because it is the flow of positive charges. So if electrons move towards this side, it's equivalent to say positive charges are going the other way, and hence the current is going the other way. Also, the electrons move at a certain speed called as the drift speed. So the electrons are moving in the conductor at an average speed of drift speed, and there is a formula for that. So let's see all those things. So first of all, current is flow of charge per unit time, so charge by time, or dq by dt if it is instantaneous current. Current density is current per unit area, and you can relate current with drift speed using this formula. I is equal to NVDR. I NVD, VD is drift speed, into E into A. What is E? Electron charge. What is A? Area. What is I? Current. What is VD? Drift speed. What is N? It's the number of electrons per unit volume. That will be given to you. Okay, that will be given to you. Okay, Ganesh, it will be done by January for sure. Okay, let's see how many of you can solve this question coming up on your screen. The charge on an electron is this much. How many electrons do you think will pass in 1 second if 1 ampere of current is passing through that wire? Yep, it is free electron density, correcto. Let's see how many of you can do this. What's the amount of charge that is flowing in 1 second? Let's see how many of you can do this. How many electrons are crossing per unit time? Now we all know current is charge which flows per unit time. Now the charge will be the number of electrons into each electron charge divided by time. So N by T will be equal to I by E. And what is I? Current, which is 1 ampere. What is E? It's 1.6 into 10 to the power minus 19. So 1.6 into 10 to the power minus 19, I think when it goes on the top, yep. So this will be 1 by 1.6 into 10 to the power plus 19. 1 by 1.6, that's going to be close to 0.625. So I think this should be the answer. Option D, correct. Perfecto. Yes. Some of you are very sure about it, and it is. Next question. What's the drift speed given, okay, for a copper wire? Area is 10 to the power minus 7 meters square. Current is 1.6 amperes, and the density of the electrons is given to be 9 into 10 to the power 28. Let's see how many of you can calculate this very quickly. So which formula will we use? Think. Obviously current is NVDR. That's the shortcut way of remembering it. The current is 1.6. Number of charge carriers is given to be 9 into 10 to the power 28. Drift speed, I don't know. Electron charge 1.6 into 10 to the power minus 19. And area is given to be 10 to the power minus 7. I think so many things might get cancelled, like 1.6 and this 1.6 will get cancelled. So I think drift speed will be, bring this 9 on this side, so 1 by 9, 10 to the power minus 28 when it goes there, 10 to the power plus 19 when it goes to the other side, and that will also become 10 to the power plus 7. So this will become 1 by 9 into 19 plus 7, 26, minus 28 plus 26 is minus 2, so into 10 to the power minus 2. So 1 by 9 into 10 to the power minus 2, 1 by 9 is nothing but 0.11 into 10 to the power minus 2, which is 1.1 into 10 to the power minus 3. So that should be the answer. Yep, perfecto Ishwar, perfecto, that's the answer. 1.1 into 10 to the power minus 3. Hello Bhavya, welcome. Oh no, it's not 0, it's not 0. Hi Nayan, welcome aboard. Yep, yeah. So 1.1 into 10 to the power minus 3 meters per second. That's very small, that's teeny meeny. Okay, it's a very small value. Okay, Ohm's law, though everybody knows V is equal to IR. V is the voltage, I is the current, R is the resistance. But is Ohm's law valid all the time? No. There are times when it is not valid, and you will be studying that in semiconductors. So only those devices which follow voltage is proportional to current are called as ohmic devices. Non-ohmic devices, you will see voltage is not proportional to current. Remember that. Okay, so that's one thing. Resistance is how much the current is resisted for a given voltage. Resistance is rho L by, what is rho? Resistivity. What is L? Length. What is A? Area. More length, more resistance. Big area, less resistance. Rho depends on material, whether it's made of aluminum, whether it's made of copper. So more the resistivity, it has very less conductance. Okay, keep this in mind. So if it has more resistivity, that means it will resist more, it will conduct less. So good conductors will have low resistivity. Also resistance depends on temperature, and the formula for that is R is equal to R naught 1 plus alpha delta T. R naught is original resistance, 1 plus alpha. What is alpha? The coefficient of thermal resistance, and delta T is how much you change the temperature by. So when the moment you change the temperature, you will see the resistance will also change. Moving on to some questions. Okay, and here we have the first question based on graphs. So the question says we have two graphs and we have to figure out, at which temperature is the resistance higher. Okay, come on, think about it. It's given in the question, there are two temperatures T1 and T2. Which temperature do you think is the resistance higher? Is it for? Okay, come on, think. 1 or 2. Okay, R, V and I. V is equal to IR. So V by I is equal to R. V by I over here is nothing but the slope. Correct? It is nothing but the slope. So more the slope, more the resistance. Right? More the slope, more the resistance. So this is higher resistance and this is lower resistance, as simple as that. At which temperature is the resistance higher? Obviously T2. Done, done, done. Got it? Yep. Where is T3 coming from? Alright. So that's the answer. So resistance is higher at T2. As simple as that. You have to look at it from the slope perspective, not T1. Many of you made that mistake. You would have definitely lost that mark in the CBSE board examination. Be careful. Okay. Moving on. A cylindrical rod is transformed by changing its length. How? Twice. Keeping the volume constant. If originally the resistance of that rod was R, then what do you think the new resistance will be? Yes, the resistivity will also depend on temperature. Just like R is R naught 1 plus alpha delta T, you can also write it as rho is equal to rho naught 1 plus alpha delta T. It's the same thing. Okay, doesn't matter. Okay, let's see how many of you can get this. Many people have started telling that it is B or C. Interestingo. I'll tell you what. If this is that wire of certain length L and area A, resistance is rho L by A. We all know volume is area into length. So area is volume by length. So substituting area here, you will get rho L by volume by length. So it will be rho L square by A. So that's resistance. Now rho is constant. Area is, oh sorry, I think I had to put V over here, my bad. Okay, this was supposed to be V. Okay, now the volume is given to be constant. So this will not change, this will not change. L is made 2 times. That means the square of it will be made 4 times. That means the resistance will become 4 times. That's the answer. Perfecto. It's answer C, not B. Many of you made that mistake. You thought length. Sir, length will become twice. You forgot the area will also change. When you stretch it, it will become smaller. When you compress it, it will become wider. You forgot the fact that area will change and volume is constant. That's why it's not B, it is C. Understood? Clear? Be careful. Read the question carefully. Okay, Ishwar, that's what I said, bacha. The volume is constant, not the area. So that's the reason why I first converted it into volume. Volume is area into length and area is volume by length, and I substituted it and I saw L square. The moment it is L square, so length become twice, length square will become 4 times. So resistance also becomes 4 times. Yep. If area is not given to be constant, then you should always assume the volume is constant. Okay, always assume the volume is constant, just like the one in the previous question. Okay, this question exactly. So next, going up to the next question. If there are 2 coils which are connected in series one after the other, 600 and 300 ohms, 20 degrees Celsius, and the temperature coefficients are also given, find the new resistance at 50 degrees Celsius. So we have 2 resistors in series. This is 600 ohm and this is 300 ohm at 20 degrees Celsius. But obviously the resistances will change at 50 degrees Celsius. Basically my delta T is 30 degrees. So the question is, what's the new resistance? So the new resistance, obviously, let me just put it here. So the new resistance in series will be this plus this. So R1 plus R2. R1 will be R0 1 plus alpha delta T. So R0 is 600 into 1 plus alpha. What is alpha? Alpha is nothing but 0.001 into delta T. 001, yes, into delta T. Delta T is nothing but 30. Okay, just put it here. Plus R2. R2 will be again R0 into 1 plus alpha delta T. So 300 into 1 plus, what is that alpha? It is 0.004 into 30. That's it. So once you get this, just solve this. 600 into this will become 1 plus 0.03, okay, plus, so that means it will become 1.03 into 3. 6 3s are 18, so 618. So that's the first term. Is that correct? Everybody got this first term? What will be the next term over here? Let's see. It will be 300 into 1 plus. Okay, 4 3s are 12. One of the zeros go. So it will be 0. So that 12, 1 will come over here. So that's what you will get. Everybody fine till this point? Yeah, everyone? Very good. So 12 3s are 36. So this should be 336. Correct? So 618 plus 336. Okay, so that's going to be 4 and this will be 5 and this will be 954 ohms. See if you got this. Okay, come on. Okay, let's see how many of you got this. 2 into 10 to the power minus 3. What is 2 into 10 to the power minus 3? Where is 2 into 10 to the power minus 3? There is no 2 into 10 to the power minus 3. That's it. That's the answer. Okay. So just check your calculations once again. Yeah. All right. Let's move on to the next one. Oh, by the way, these kind of questions can come in case studies. Let me tell you that. Yep. They might tell you everything about, something like temperature dependence on resistance, and then they will give you a question on that. So be careful. Okay. So 954 ohms. Yes, it is. Okay. Let's do a question on resistance color coding, and let's see how many of you can solve this question. Okay, so you should remember this chart. Yeah, B.B. Roy of Great Britain had a very great wife, gold, silver and none. These are the numbers which start from 0 till 9. So if you remember, the first color is always the first digit, the next color is always the second digit, the third color is always the power of 10, and the fourth band is always the error percentage. Yep. Oh, it's deleted, is it? Oops. Okay, then I don't think I should solve this. Okay, let me just skip this then. Okay, chalo, let's move on to this one. So equivalent resistance for different combinations. Let's try to solve some problems on equivalent resistance. So resistors in series, they add, the current is same. Resistors in parallel, 1 by R1 plus 1 by R2 is the effective resistance. Let's solve questions on resistance. Come on. In the circuit shown in the figure, the resistance is given to be 55 ohms. The equivalent resistance between these 2 points P and Q is going to be very, very interesting. Let's see how many of you can solve this. What's the equivalent resistance between P and Q? Okay. So first of all, I can again see certain points to be equal. This point, and this point. Same wire. This point and this point are same. This point, and this point. Again same. Now I can see these 2 points and these 2 points, R and R, I think these two are in parallel. Can you see that? They are basically in parallel. These two resistances are also in parallel. So two resistors equal, R and R in parallel. What's their equivalent? R and R in parallel. What's the equivalent? 1 by R plus 1 by R, 2 by R. Flip it, R by 2. Correct? So let's redraw this circuit and see what do we get. So from P, the first resistance that I will get is R by 2. These two together. These two together will also be R by 2. Fair enough. So that's what I have drawn till now. This is that dot, this is that cross, this is that circle. Perfect. And from here, this is point Q. Then on this side, what do we have? On this side, we have this R. We also have this R. And yes, there is a wire connecting like this. Fair enough. Fair enough. There's a wire connecting like this. Okay, now I think I got an idea what to do. This is a wire. So this is also a circle because this is going to be at the same potential. Now you can see cross circle, cross circle. So don't you see that these two basically are going to be in parallel? Cross circle, potential difference is same. So I'll redraw the circuit. So point P, okay, then you have this R by 2 and over there this R. These two are in parallel. So if these two are in parallel, what is their equivalent? Calculate it quickly. So R into R by 2 upon R plus R by 2. So that will be R square by 2 divided by 3R by 2, which is R by 3. Perfect. So this resistance, when I combine them together, it will be R by 3 and that is directly joint at Q. You can see that when their combination is directly joint at Q, and this R is also joint at Q. You can see that. This R is also joint at Q. Now just solve this. This is easy. R by 2 and R by 3 together. What will it be? They are in series. So R by 2 plus R by 3. So that will be 5R by 6. 5R by 6 and R. What are they in? Parallel. So the equivalent resistance will be R into 5R by 6 divided by R plus 5R by 6, which will be 5R square by 6 divided by 6 plus 5, 11R by 6. 6 goes, RR goes, so it will be 5R by 11. But R is 55, so 5 by 11 into 55. 11 into 55, so this will become 5. 5 5s are 25. So 25 ohm should be the answer. Check this out. 25 ohms. Perfect. Very good. Some of you got it. So what has happened is, it's all based on finding equipotential points. These 2 points same potential, these 2 points same potential, these 2 points same potential. Why? Wire, wire, wire. So these two are in parallel, these two are in parallel. RR parallel, R by 2. RR parallel, R by 2. So that's all I have done. I just condensed this circuit into this circuit. There is a wire here. So cross and circle, cross and circle. So these two resistors have same voltage difference. So these two are in parallel. So I connected them together. I got equivalent as R by 3. This is as it is. This one as it is. But this R is connected directly to Q. So I just connected it to Q. Now it's a simple series and parallel combination. Done. I hope this is clear. Yep. So if you get these sums, you can leave it as option. Yep. So you have to choose. Okay. There could be some difficult questions. Yep. Yes, it is lengthy. There will be some difficult questions. I have told you, even in the sample paper, there are difficult questions if you have noticed it clearly. Okay. So moving on, few more questions, and here we are on the bulbs related questions. Okay, come on. So we have bulbs over here. Which bulb do you think will be the glowing brightly? Yep. Which of these following bulbs do you think will be glowing really bright? Come on, my warriors, think about it. Yep. Think carefully. Yep. All the bulbs in the circuit shown in the figure are identical. There will be only one of these few bulbs which will be glowing really bright, and the brightness depends on the current flowing through it. So it's basically how much current is flowing, and you can just see. Yep. Priya Siva, I have already solved the sample paper questions in one separate class. You can watch it. You can just search for sample paper Shreyas sir CBSE. You will get the video. So the current which will glow, the current which will go over here will go like this. It will get divided. It will get divided and again come over here as I. Obviously, this will be less current. This will be also less current than I. So this will have same current as this, but these all will have less current, so their brightness will be less. So 1 and 5. Is 1 and 5 there somewhere? Yes, option D. 1 and 5 will be the brightest. Okay, perfect. Based on distribution. Okay, let's solve some questions based on internal resistance. Every battery has some internal resistance in reality. So the actual voltage between the two terminals is the EMF minus IR. I is the current, R is the internal resistance. Keep this in mind. Okay, so the actual voltage is never E unless and until the current itself is 0. So if current is 0, obviously voltage is V, but whenever current flows, the actual voltage is slightly less because of the voltage drop. So based on that, yep. So is the voltage across all the resistors same? If they are in parallel, yes. If they are in series, the voltage drops could be different. Okay. So we have a battery of certain EMF. Internal resistance is also given. The current in the circuit is also given. What's the terminal voltage between the terminals of the battery? Come on, think. So you have this battery. The question is, what is the terminal voltage? That means think of the battery like this. Think of the battery like this. What do you think is the voltage? I just gave the formula. It is E minus IR. Just use this, you will get the answer. Perfect. Okay. Rachna saying D. Cholan also saying D. Voltage will be E. Come on. What is E? It's given 10 minus. What's the current? 0.5. What is internal resistance? 3. So that will be obviously 8.5. Is it there? Yes, it is. Perfect. Moving on to the next one. Here we have a next question based on graphs. And what does it say? We have a cell whose voltage and current vary given by this particular line. So when the current is this much, voltage is this much across the terminals of the battery. So the question is, what is the EMF and the internal resistance of that cell? Come on, let's see how many of you can solve this. What's the voltage and the internal resistance? I'll give you a hint. Voltage is given by E minus IR. Voltage as a function of current is a straight line equation, and that's the equation of that straight line. Just have to solve it by putting values. See, for example, for this point, okay, for this point over here, the voltage is 2, EMF I don't know, current you can see is 0, internal resistance doesn't matter. So clearly E is nothing but 2 volts, just directly from this point. Similarly, if you go to this point over here, the voltage is 0, the EMF I just calculated it to be 2, minus current is 5, resistance I do not know. So basically 5R is equal to 2, R is equal to 2 by 5 ohms. That's it. So 2 by 5 ohms and 2 volts. 2 by 5 is 0.4 and this is 2 volts. Yep. So I think it should be this one. Yep. That's it. Option B. Oops, many of you made a mistake, I think. Many of you made a mistake. It's option B. It's not option A. I don't know why you said option A. So it's option B. Be careful. Yes, it is. It is option B. Okay, many of you lost marks. Many of you. Thank God you're attending this class. You should be very, very happy. Okay, Kirchhoff's laws based questions. Let's do this. If the battery is charging, then it will become E plus IR. Okay, so that's the difference because it is charging. Then it will be more. So first is Kirchhoff's current law. The current which is arriving and leaving together, the current which is coming in and the current which is going out is always equal. That's Kirchhoff's current law. And the Kirchhoff's voltage law. The sum of the voltages across a loop is always 0. Okay, these are the two laws. Let's do the questions based on this. Here we have it. We have this circuit using KVL. This can come like a case based or passage based questions in your CBSE board exam. Okay, and you have currents given here, but this current is not given. You have to find current I2 and you have to also find the voltage across the R. Well, let's try to solve this question first of all. So if you look at this particular arm, okay, so if you start from point B and go till point A, then also you can apply KVL, although it does not complete a loop. Many students do not know this. Usually students start from a point and come back to a point. But even if you start from a point and go somewhere else, you can apply Kirchhoff's law, but it is not a complete loop law. How can you apply it? Observe. From wherever you are starting. So basically, let's say I start from here and I end over here. What is the potential at the starting point? B. What do I encounter first? Resistance. The current is going this way, so voltage drops. So minus. Why minus? Because voltage will drop across the resistance IR. So 0.5 into 2. Then I encounter the battery. I go from low to high, so potential increases. By how many volts? 3. Eventually, where do I reach? A. So what's the potential at point A? VA. That's all. That's all you need to do. So basically take VB on the other side. So you will get VA minus VB is equal to 3 minus 0.5 into 2 is 1. Basically it will come out to be 2 volts. That is VA minus VB. Everybody understood? So this is how you apply KVL when you don't go across a loop. Now, Munish Kumar, yes, I have made a separate video for solving complex circuits. It's there in the playlist of this channel itself. If you go browse through the playlist, you will find a playlist of current electricity. It's there in the physics section. There are sections, maths, physics, strategy, etc. Go to physics. In that, go to the playlist of current electricity. In that, there is a special lecture just for solving problems on circuits using KVL, KCL or any symmetry method. Just watch that. Now, once you do this, now think A and E are at the same potential. Wire. B and F, same potential. So this will be equal to voltage between E minus voltage between F. Makes sense? Also, undoubtedly, if this is EF and this is G and H, E and G, same potential. F and H, same potential. So this is also the potential difference between G and H. And what is the potential difference between G and H? That is nothing but voltage difference across the resistance. So I think I just found out the first answer. The voltage drop across the unknown resistance is 2 volts. First answer is done. Understood? Yep, it is of CBSE level. Yes, Monish, you should know how to apply KVL. Next thing, E minus F. Just again, this can come like case study, bachcha log. So between E and F, again apply KVL and see what do we get. So start from F, start from here, end over here. So VF, what do I get first? Resistance, so minus IR. So minus I2 into R, which is 2, plus, because I get a battery of how many volts? 4, will give me VE. So VE minus VF will be 4 minus 2I2. But VE minus VF, I already know it is 2. So it will be 4 minus 2I2. So 2I2 will be 2. So I2 will be 1. So this answer is also found out as 1 ampere. Done. Perfect. Perfect. So that's how you apply KVL in circuits. Just choose one point, go to some point, apply what is increasing, what is decreasing. Accordingly, you put pluses and minus. Let's go to Wheatstones. So what is Wheatstones? You have 4 resistors or 4 capacitors also. That's fine. R1, R2, R3, R4. And you have 2 points between those 4 resistors which you can completely ignore if this ratio is balanced. If this ratio is there, then it is said to be a balanced Wheatstone. This also works for capacitors. If you have capacitors like this, okay, and for example, you have some device over here. If this is C1, this is C2, this is C3, this is C4. If you see C1 by C2 is equal to C3 by C4, then, okay, then you can forget whatever is there in between. Then it is said to be a balanced Wheatstone bridge. Keep this in mind. Okay, it works for both the resistors and capacitors. The ratio should be same. And that's the principle on which you have the meter bridge. Yep, meter bridge is based. The meter bridge is exactly based on this concept. I'll explain to you briefly what it is. So here what do you have? You have a battery. It is powering the circuit. The current goes into this resistance and this resistance, as well as this entire wire AB is one resistance over here, but you can divide it into 2 resistors, something like this. Let's say this is one resistor, this is one point, and this is another resistor. Now you can see it's like a Wheatstone's bridge. Resistance 1 here, resistance 2 here, another resistor here, and another resistor here, and some device connected over here. If it is balanced, then there will be no use of this device and there will be no current in the circuit. So on this wire you move this point till no current flows, and when no current flows, what is that point called? It is called as a null point. And you will see at the null point, then no current flows. This resistance by this resistance is this resistance by this resistance. But do not forget, resistance is directly proportional to the length. We have seen this. That's the formula for resistance. So hence, this resistance by this resistance, which is also resistance 1 by this resistance 2, will be length 1 by this length, which is 100 centimeters minus L1. Okay, so that's how this formula comes. Okay, is that clear, my warriors? Is that understood, my warriors? Okay, so let's do some questions based on this. Okay, it's all there in the syllabus. So let's do this. Come on. So we have a meter bridge. The length of the wire is 100 centimeters. At what position do you think the balancing point will be obtained if the 2 resistors are in the ratio of 2:3? If they are in the ratio of 2:3. Come on, let's see how many of you can do this. It's very simple question. The resistors are in the ratio of 2:3. What do you think will be the balancing length for this? Come on, think about it. So we have a meter bridge and we need to figure out at what position will the balancing point be obtained. So I'll tell you what. The length of the wire is 100 centimeters. This is the balancing point, which is at a distance of L1. The remaining will be 100 centimeters minus L1. Ratio of resistances, R by S, is ratio of lengths. I just told you, L1 by 100 minus L1. So R by S is given to be 2 by 3. This is L1 by 100 minus L1. Cross multiply. So 200 minus 2L1 is 3L1. So 200 is 2 plus 3 is 5L1. 5 divided by 200, that's 40. 40 is equal to L1. So that's 40 centimeters. That's the answer. How many of you wrote it? Perfect. Some of you wrote 50. I don't know why you wrote 50. The answer is 40. Straightforward formula. So that's why you should not skip it. Yeah. Perfect. Yep, 40 centimeters. Yep. Potentiometer. This is another important device which you should know. and that is also used to measure EMF of a battery, internal resistance, or also the voltage. And it is made of two circuits, primary circuit, secondary circuit. So in case of a potentiometer, remember this primary circuit supplies voltage. It creates potential gradient over here. It creates potential gradient over here. So on this potentiometer wire, which could be of generally 100 centimeters, you will see there will be some volts per meter. There will be some volts per meter which is created across that potentiometer wire. Now what you do, that secondary circuit, this is the secondary circuit, and if the voltage across the secondary circuit equals the voltage across these 2 points, then there will be no current which will flow over here, because if this voltage matches exactly this voltage, there is no reason for the current to flow between them, and then you again get a null point. So the basic working principle of a potentiometer is you find two such points between which the voltage is same. You find two such points between which the voltage is same as your secondary circuit, and then you will see the galvanometer will not have any current, and that's when you get your balancing length. And what are the important formulas? First, comparing batteries. So primary circuit again, first time you connect first battery and see where is the balancing length. Let's say it is L1. Second time you remove this battery, use the second battery E2. Then you see where is the new balancing length. Let's say it is L2. Then the formula is E1 by E2 is L1 by L2. Keep this formula in mind. Keep this formula in mind. Yes, Deepak, I just did a formula question on Wheatstone's bridge, but if you want even more problems, I would suggest please watch my current electricity playlist, where there is lecture dedicated for Wheatstone's bridge and meter bridge and also instruments. Yes, Deepak FF? Okay. Next important formula which you should know is for finding internal resistance. So when you have a battery whose internal resistance has to be found, then you connect it in the secondary circuit. What you do, connect that battery and find the balancing length. Let's say you get it at L1. Now take that battery and connect it to another resistor. So current starts flowing in this circuit. Now again find the new balancing length. It will be slightly different. So that length is L2. So the internal resistance of this battery is given by the resistance which you use here into L1 by L2 minus 1. That's the formula. Okay, so let's do one last question, probably then we are done for today. So the potentiometer wire of length 1 meter is connected to a driver cell of 3 volts as shown in the figure. When you take 1.5 volts which is used in the secondary circuit, the balancing point is 60 centimeters. When you replace this cell and use a cell of unknown EMF, the balancing point shifts to 80 centimeters. The question is find the unknown EMF. Find the unknown EMF. Let's see how many of you can do this. Okay, I'll give you a hint. Again, try to think. This is some primary circuit. You connect a battery here. You get the balancing length as for 1.5 volts, you get it as 60 centimeters. You remove this cell. You put a new cell. You get a new balancing length. Question is, what's the EMF? I just gave you one formula for comparing EMFs. What was it? E1 by E2 is L1 by L2. Remember, I just gave you that. When you use EMF 1.5, the length was 60. When you use that unknown EMF, the length was 80. 6 goes 2 times 3, this will be 4. So E2 will be 1.5 into 4. That 3 comes down, 1.5 into 4, that's 6. So 6 by 3 is nothing but 2 volts. That's the answer. It's that easy. If you know the formula, okay, you'll unnecessarily leave it thinking I don't know, but it's that easy if you understand it. Okay, chalo, that's the answer. 2 volts. Let's do one last question probably. Assertion reason. The EMF of a cell in secondary circuit must be less than the EMF of the cell in the primary circuit in the potentiometer. That's the assertion. The reason says balancing length cannot be more than the length of the potentiometer wire. Is that true or false? And if it is true, both are true, are they correct reasons, or is the reason correct reason for the assertion, or what do you think? Okay. The EMF of the cell in the secondary circuit must be less than the EMF of the cell in the primary circuit. The reason says balancing length cannot be more than the length of the potentiometer wire. What do you think? Okay, so most of you are saying A, and I think it is correct. That is always true. So when you have your primary circuit, and this is your potentiometer wire, okay, and this is your secondary circuit, and you have the secondary voltage, okay, so this is your secondary, this is your primary. You cannot have this point outside. There is no meaning of it. This length always has to be less than 100 centimeters, and that can only happen if this voltage is less than, this voltage. So the balancing length cannot be more than 100 centimeters, and the EMF of the cell in this circuit has to be less than the EMF of the cell in the primary circuit. Else you will never get the balancing length within 100 centimeters. Imagine this is more voltage. Obviously, then you will try to find bigger voltage difference. You will go outside the wire. It does not make sense. So if you want more revision to be done, if you want even more classes, if you want test series, if you still want that last chance, I would suggest there is a marathon sessions. There are plenty of sessions which are going to go on for maths, for physics, for chemistry, and for biology in Vedantu. And it is free of cost for all the pro users. Take it up, because right from your tab, right from your laptop, you can attend all these classes and give these mock tests. So how to check it out? I'll tell you. Right now, if you're watching the video, if you're watching my video right now, you just have to go down. I'll tell you what you need to do. You can see CBSE Term 1 and 2. You can see Class 12th JEE 2022. You can click on any of these links, because no matter what you choose, you are going to get those CBSE classes just for the upcoming Term 1 examination. Now, in this, you will get all the recorded classes as well as the live classes which will be conducted in the coming days. You will get mock tests, okay, with report cards. You'll also get the assignments which are not there anywhere online, and your doubts will be solved on the mobile. Now, see, I'm not even asking you to take the entire course. Don't even buy the complete course. Try it for 15 days, 1530 when you use my coupon code. What happens is, for the next 15 days, that's the time when you are going to write your board exams, you will get for free all the classes of boards, correct? Not just that, any other class also that you want to attend, that also you can attend. You can try out my courses, you can use the doubt facility, everything. So try it out and make use of it. If you don't like, don't continue. But if you feel, oh, for me Term 1 went well because of these 15 days of pro courses, then you can go ahead and continue buying the complete course, and you don't have to pay the complete amount, you just have to pay the remaining amount. That's how it is. Okay, so I would suggest you guys to try it out for 15 days. Just enter your login details, and trust me, you're going to get 10% off, yep, when you use my coupon code as well. And it was such a lovely session with all of you. I mean, it was a very long session. I also did not have my dinner just for you, because I know it's a very, very hard and tough time for all of you. So I am ready to do all the sacrifices that are needed. Tomorrow I'll be coming at 6:30. I won't come at 7:30. I'll start at 6:30. We'll be doing magnetism, we'll be doing EMI, and we are going to do AC, all of it. Okay. So yes, class 12th playlist is also there. I think it should be there in the description box. You can see that. Probably it should be there over here. Yep. Yes, look at this Pathfinder 12th physics playlist. Can you see that? This is there in the description box. Class 12th playlist. Just click on this. It will open the complete playlist of mine. Do you see all my classes? Current electricity, KVL, KCL, galvanometer, ammeter, potentiometer, advanced questions, capacitors, advanced questions, magnetic sources, EMI, everything is there. Do you see that? So all my classes are there. Okay, so don't worry, it's there in the playlist as well. Okay, so thank you for liking the video, and thank you for calling in all your friends, and thank you for hitting the subscribe button. Study well, take care, have your dinner, and take care of you too. Thank you very much for all the love, bacha log. Have a great time. Hasta la vista. This was Shreyas here.